control will route directly to our two services. Okay, it won't actually make use of the cluster IP services. They are really just used generally for container-to-container communication. The ingress Nginx control in this case is going to reach out directly to our services. Next thing we're going to do is set up a database, a SQL Server database, because at the moment we're running internal in-memory databases for both our services. So we're going to stand up a separate SQL Server just for use by our platform service. And it's going to have a cluster IP as well, so it can talk to the other services. The other thing it's going to have is access to persistent storage space, because our platform and command services, they can reboot, they don't need to store data, they are stateless. That's fine. SQL Server, it's a database, obviously it can't be stateless, it needs to store data somewhere. So we're going to use something called persistent volume claim to claim some storage on our physical disk. Now that area is starting to go into the domain of the DevOps type guys, the administrator type guys. It's not strictly developer area. Persistent volume claims, that's fine, that's a developer realm, but when you start going further down the food chain and you start talking about persistent volumes and storage classes and then setting up storage, that's starting to go into the realms of the DevOps type guys. Fortunately for us, we can just set up a persistent volume claim and that will do what we need it to do. And it kind of reaches down onto a physical disk. The final pod we're going to set up is our RabbitMQ message bus. And again, cluster IP, and it will allow us to talk to all the pods to talk together within our node. Now, one thing you'll notice here, you'll probably go, where is the SQL Server for our command service? In this video, just for the purposes of saving some time, the command service is going to have its own database, but we're just going to keep it as the in-memory database. Still has its own database, can't stress that enough. It's not using the same database as the platform service, using its own database. We're just going to keep it in memory. And maybe as a bit of homework, once you start to get familiar, you can spin up a second SQL Server just for it. But again, main takeaway, it's not got a SQL Server, but it still has its own data store. Very, very important. And then these cluster IPs, maybe not the best diagram. Basically, it's not saying that the platform SQL Server just talks to the RabbitMQ database, blah, blah, blah. It basically means all these four things can talk together. Okay, they're all chained together, they all talk together. Maybe not the best diagram. But yes, this is our end state. This is what we're going to set up. This is what we're going to build. And as we move through the rest of the video, we're going to refer back to this time and time again to make sure that we are making progress. So with that, I think enough theory. We're now going to move on to creating our first pod in the next section. All right, so back over on our application, just make sure you don't have anything running. And what we're actually going to do is we're going to move out of just working within the platform service project, and we're going to basically work within a kind of more, I suppose you'd call it a solution type context rather than just a project context. So in your command line, if you just come out of the platform service, and so we'll do a directory listing and you'll see that we have the platform service there. And I'm just going to come up one more level and do a listing. Now, all my solution is going to be within this E3 folder here. So what I'm going to do is type code R-E3. And that's going to reopen Visual Studio Code. And we've still got a platform service here. You can see everything in here, but we're now going to create another kind of project level folder. I'll just say yes to that. All right, and that's going to contain our Kubernetes assets, mainly our deployment files. So when you're working with Kubernetes, there's a number of ways you can set things up. You can run things at the command line to deploy pods and do all that kind of stuff, or you can write files, deployment files. And that's the approach we're going to take because it's much more reusable than doing stuff at the command line. So in our in our solution context now, we're going to create a new folder, and I'm just going to call it K8. Now, as I said in the previous section, K8 is really just related to the Kubernetes stuff that we're going to be writing. So it's not a .NET project or anything like that, it's just going to be a bunch of deployment files. So the first thing, as per our diagram, and if we maybe just pay it a little visit again, if we come back over here, I'll just bring it back up on screen. I'll need to get a more static version of this. Yeah, the first thing we're going to do, actually, yeah, that's actually working okay, is deploy a pod with our platform service in it. That's what we're going to do next, and then we'll come on and do the node port. But for now, that's what we're going to do. So within our K8s folder, right click, new file, and we're going to create a deployment file for our platform service. So we're going to call this platforms-depl.yaml. Okay, so it's a YAML file, as the name would suggest, and depl obviously is just short for deployment. All right, so I think probably the best way to approach this is just to start typing it out and trying as best I can to explain it as I go through. It's a bit long-winded, and there seems to be, you'll probably think there's a bit of repetition in this file, but everything is necessary, unfortunately, and YAML files, yes, are white space sensitive, so just be careful as you work through them. But if you follow along, should be okay. And remember, the code is on GitHub, so you can pull down this file if you do run into problems following along yourself. So the first thing we specify is an API version. So colon and it's apps /v1, and that's just specifying, yeah, the API version that this deployment file is going to use. Under the covers, Kubernetes actually works with basically a REST API essentially to create and destroy its own resources. So that's basically what we're specifying there. What kind is it? Well, it's going to be a deployment. So again, we're deploying something into Kubernetes, and as we work through the course, we'll have different kinds of these files. I don't want to populate it with all that stuff. Next thing is metadata, and we give it a name, and this is really just the name of our deployment. Okay, so we're going to call it platforms-depl for our deployment, basically. And then we come on to our specification, and this is really where we specify our pod effectively. So tab in, and the first thing we're going to specify is the number of replicas. Now, as I said when we were talking about Kubernetes, you can horizontally scale out the number of services that run. So we could have 3 instances of our platform service running if we wanted, and that's what's referred to as a replica. Here we're just going to have a single replica. We're just starting with one, at least to begin with. Now these next, there's going to be 2 bits that follow. Let me just type them out first, and then let me describe them, because they're a wee bit confusing, to be honest with you, but yeah, again, they're mandatory. So the first thing is selector. And we come down and indent once again, and then we type in match labels, and it's actually getting some help with it. And then app, and we're going to call it platform service. Now we're going to back out again. We're going to stay within our spec, but we're going to be directly under our replicas and our selector tag now, and we're going to define a template. We're going to give it some metadata. Don't forget the colons, tab in. And again, you've got to be really careful with this white space here. And we're going to give it a label, or labels. And we're just going to give it a label of app, and again, platform service. We'll just select that from there, basically. Now these 2 things, the selector and the template, kind of work in combination with each other. And really what we're doing within this template, it's within here that we're really defining the pod and the container that we're going to use. And then this selector is basically selecting the template that we're creating. Okay, so it's a wee bit kind of convoluted, but this template stuff is where we're defining what we're deploying, and then the selector is basically selecting it for us as part of the deployment. And then under there, we're going to back out to underneath metadata, so we're still within our template section, but directly under metadata now. And this is where we're going to define our spec. And under spec, tab in, and we're going to specify the containers that we want to run. And we're almost at the end, don't worry, we're almost getting there. And anything within YAML that has this kind of minus sign, that's an array. And you can even see by the name containers, it's plural. You could have multiple containers that we wanted to deploy. But in our case, we're just deploying one. We're going to give it a name of platform service. And what I want to do is just select this and make sure that we have these 3 things are called exactly the same thing. So the match label, the template app label, and the name of our container are all platform service. And then finally under here, just tab in under the name, we want to define the image, and this is just the Docker image for our service. So image colon, and we just specify binary thistle / platforms service. And obviously make sure this name is the same name as the service that we have defined or you have defined. And again, remember, this will be your Docker Hub login ID. And we do actually want to specify latest here, okay? Now this complaining is just complaining about, we're not putting a couple of other things to do with resourcing limits. I'm not going to bother doing that, so I'm going to ignore that kind of warning. Now that's it. That's basically a deployment for a container into a pod, okay? So if you save that off, we'll find out if we have made any mistakes, but it looks okay for the moment. So again, probably for me, the most confusing thing is this selector thing, but really all it's doing is it's selecting this thing here that we've defined as part of our template. That's really all it's doing. Now we're going to come back in here a bit later and we're going to define our cluster IP service in here as well. If you remember from the previous architecture diagram, we're not going to put it in yet. We're going to do this all step by step, one step at a time. That's cool. So remember to save off, and yeah, now having defined our deployment file, we're going to actually effectively run it and deploy it into our Kubernetes cluster. All right, so back in our application, we are going to bring up a command prompt. Fantastic. Now, before we do anything else regarding our platform's deployment, what I want to do is just make sure that Kubernetes is running appropriately. Now, I believe I did anyway, bring over Docker Desktop, and I said to check that you have Kubernetes enabled and that it's got the little running instance down here. And that's looking all good. But one of the other things that we rely on as part of Kubernetes, and this is sort of starting to go into the architecture of Kubernetes itself, is basically the command line that we are going to use to drive all of this stuff. And the command line is kubectl, okay? And so if you type kubectl version, this is the command line tool we're going to basically use to issue all our commands. You'll see, hopefully, if it's running correctly, you'll see a client version and a server version and all that kind of stuff. Doesn't really matter what the versioning is, just so long as you get something back. That means Kubernetes is up and running and the kubectl command line is all good to go. So let's clear the screen. And again, all these commands, or most of these commands, are in the cheat sheet that I talked about at the start of the video. So let's just do a directory listing where we are. We're in the, oh goodness sake, we are in, oh my goodness. We can see that we've got a platform service and we can see we've got a K8s folder. So we're going to change into our K8s folder and do a directory listing to make sure that you can see this platform's deployment file. And we're now going to apply that file. And so it's kubectl, apply, F, and then the name of the file. So this is platforms-depl.yaml. And if there's any issues with it, you'll get an error at this point in time, but that looks okay. So we've got a command that comes back saying deployment apps platform depl created. Okay, what does that mean? So if we do kubectl get deployments, because basically we've created a deployment. I'm going to spell kubectl wrong. There we go. You can see here that we have something called platforms depl, 0 containers ready or 0 pods ready, and 1 is up to date. So let's keep an eye on it. But the other thing you can do is see your pods running. So kubectl get pods. Now you're probably starting to see a bit of a pattern emerging here. With this command, you can use kubectl get whatever. So you can get deployments, you can get pods, you can get services. You can see here that we got 1 pod within our cluster now, and it's ready and it's running. So that looks good. Let's just get deployments again. And you can see now that 0, from 0 being ready to 1 being ready, it's all up and running. That looks really good. Okay, so I think if we come over to our Docker plugin, you can actually see here that we have a running container. running in Docker, but isn't it supposed to be running in Kubernetes? Well, yes, obviously it is. Kubernetes is orchestrating it, but it still has to run in Docker. Now, what I'm going to do is I'm actually just going to delete these two containers that we had created in the previous section because it's just going to get way too busy. All right. Now, the other thing I want to do then is come over to our Docker desktop. And if you come over here, it's making itself rather big, and we just go into General, actually cancel out this, and we come over into the kind of main window. Actually, to be honest with you though, I actually find the Docker desktop interface can be a wee bit confusing sometimes. So if you go into settings, this is where our settings are, and you cancel to come out of that. This is kind of showing you running stuff. Now, the first thing you'll see is, well, wait a minute, there's actually two things running here. How is that possible? Well, this is a pattern that you'll see sort of time and time again. This is actually the running container. And this thing here, as you can see from the name, is actually the pod that's kind of running. So you can click on that, the actual container one, and you can look inside and you can see basically output from our service running in Kubernetes. And it looks very familiar. It's seeding data because we've got using an in-memory database. And you can see here, it's listening on port 80, which is basically what we saw when we ran it in Docker as well. All right, so that's all looking really good. So give yourself a round of applause. You've created your first deployment and you've deployed a service into Kubernetes, and it's running and waiting for us to start using it. Fantastic. So in the next section, what we're going to do, we're going to do a little bit more work here just to show you some of the things that Kubernetes can do and how it actually orchestrates services. And then we'll eventually come on to working with our node port. All right, so one of the things I want to show you, and it's one of the things that kind of confused me a little bit about the whole Kubernetes setup was, okay, what happens, and maybe this is my destructive nature, what happens, here's our running container here, what happens if I delete this? Okay, so let's stop it, and let's delete it. Let's remove it. What happens then? Anything. So if we come back to our command line, and we do, let's do upkey kubectl get pods, you can see that we've got our pod here, and it's saying 0 of 1 is ready. If we do it again, it's now saying 1 of 1 is ready, and you can see now that a container is running again. And we come back over to Docker desktop, you can see that we have the container has come back. We've stopped it, we've destroyed it, but it's just bounced back and come back up. How is that? Well, that is one of the whole points around the Kubernetes. It auto recovers your containers for you. So if a container crashes, for example, something bad happens to it, because we've told Kubernetes as part of our deployment, come back to our file over here, and look at our deployment file. Because we've told it, we want a deployment, we want one replica, Kubernetes is going to do everything in its power to ensure that there is one replica of our service running. So even though we explicitly destroyed it there, it still came back and runs again. So you can change that behavior if you want, but the whole point of Kubernetes is that you've told it to do something, you've given it the end state, it will make sure at all times that that end state that you've specified is being adhered to. So that's one of the very, very cool things about it. Now, that's not to say that you cannot destroy things, because that's kind of what I thought originally. You can. So again, if we come back to our command line, you can do something like kubectl. Actually, let's get our pods, get our deployments first. So kubectl, get deployments. And we have our list of deployments, and then we can go kubectl delete deployment. And we'll take its name, and we will delete the deployment. Okay, do a upkey, get deployments. There are no resources found. And if we come back over to our Docker desktop Kubernetes instance, you can see basically it has destroyed everything. We've destroyed the deployment, we've told it to delete the deployment, and there you go, it's taken everything down. All right. So just one other thing, just to show you how easy it is to tell Kubernetes to run 3 instances of our service. We can just change the number of replicas to 3, save that off, upkey, and we'll go back to our apply command. So kubectl apply f platforms depl YAML, and we will hit enter. And clear the screen a wee bit here, and if we do kubectl get pods, you'll see that there are 3 pods. They're not started yet, but Kubernetes now is attempting to start 3 containers for us. And if we keep refreshing this, it will eventually, unless there's an error in our image, it will eventually reflect the fact that we have 3 running containers as part of our cluster. Okay, so you saw how easy that was. So again, the idea is if you're seeing high traffic on one particular service, you can quite easily spawn up 2, 3, 4, however many services, and you can deal with that increased demand. Of course, there are design considerations with the way you built your service. That there may be other things you have to consider, but in our case, it would literally be that easy. So you can see here, we've got 2 containers up and running, and this other one is in this container creating state. So it's still spinning up, and I'm sure eventually you will see all 3 will have started. So unfortunately for those 3 containers, there they are, they're all up and running, and we come back over to our Docker desktop view. You can see that we have our 3 services running, and then we have 3 associated pods, 1 for each platform. And that's a pattern that you're going to see time and time again. You're going to see these pods paired with a service. All right, so no sooner had we spun that up, I'm going to delete it because I don't want three services running. So we'll upkey, and we'll delete deployments platforms depl, and then we'll do get deployments, kubectl get deployments. And we have no resources found, which is correct. And we'll just double check. Yes, it's in the process of deleting. That's cool. So I'm going to come back here before we move on, change that back to 1, save it off, and then for not for the last time, but the last time in this section, we're going to reapply our deployment and get our 1 service up and running. So that's all good. We have a service up and running, but we have no way of accessing it yet. So we're now going to create a node port that will actually give us access to see if we can query this service running in Kubernetes. So we'll do that next. All right, so we want to create a node port now, and a node port is one of a few different types of service that we can create. But just before we do that, just run a kubectl get pods, just to make sure that the pod that we kind of recreated, or the deployment that we reran in the last section with our 1 pod is now up and running. So we have 1 pod running, that's cool. So just make sure you do that before you go any further. So yeah, we want to create a node port now. So if we maybe just come back to our diagram, it's probably worth just taking a quick look. So we've done this now, well done. We're now going to create a node port, and that's going to allow us external access into our service. Now, you'll see on here, we are going to create a node port. We're going to specify this port here, which is just referred to as, you'll see in a minute in the file, the port, and this one here, this 80 is the target port. We don't specify this 30,000 port. Kubernetes does that for us. So we specify 2 ports, this one here and this one here. All right. So back over in our K8s folder, if you right click and do new file, I'm going to call this platforms np-srv just to keep it kind of short. So .yaml, don't forget the YAML. So platforms node port dash service.yaml. All right, so I might just pull this down a little bit. And over in our folder, in our file, sorry, we're going to specify an API version again. This time it's just v1 as we're dealing with services. The kind this time is going to be a service. Whoop. I don't really want it to auto-complete it for us, so a service. Again, our deployment was a deployment type. This type is a service type. And we're going to specify some metadata. And this is really just the name that this service will be known as when we kind of work with it at the command line. So I'm just going to call it platform np service-srv. Okay, platform np service-srv. Yeah, okay. Some of these names can get a bit unwieldy, so you have to be really careful that you type them in correctly. And then we specify a spec section, tab in, and the type, in this case, is node port. And then we're going to work with our selector. I'm going to specify the app. Now this is where we pop back over to our platform's deployment file and we pick this value here, platform service, okay? So it's basically, it's another selector and this is what we are. We're selecting the same thing. Okay, this node port is going to be working with this platform service. It needs to know where to reach out to. And then we come back and then we specify the ports. So we're going to specify a name. For memory, the name thing is not mandatory, but I'm going to put it in anyway. I'm going to give it the same name as this. I think you need it if you're specifying more than one array of port types. And you can see here, this is an array that we're defining, or array element, should I say, that we're defining. So protocol is just TCP, port is 80, and again, that's the port on the node port, and then target port is the target, it's the port of the service that we want to talk to. And that should be it. And again, yeah, if we were defining another, set of ports, then you actually do need the name in that case. If you're just defining one, I don't think you need the name, but we'll leave it in anyway. It makes for more descriptive reading anyway. Cool, so we'll save that off. Now in a very similar way that we did with our deployment, all we need to do is do kubectl, apply, f, and then the name of our file. Now actually, maybe before we do that, we'll just do well, I can see we're in the folder, but just do a directory listing to make sure that you're there. And yeah, let's go for it. kubectl, apply -f, and then it's just the name of the file that you want to apply. Great, and again, we can see we've got a service created. If you don't see this, you will obviously see an error. Again, the errors, I think I've said this before, maybe I've not. If I haven't, the errors are quite good. They're quite descriptive. They usually get you to the root of the problem if you have made a mistake. So, although it said created, how do we know for sure that it's created? Well, you use kubectl again, get services, and you can see that we have two services here. Now this one here was actually here by default. It's there already, so we can kind of leave that one for the moment. Don't need to worry too much about that. But this is the one that we have just created. So here's the name, as we specified up here in the metadata, and then you can see that it's a node port, and you can see port 80 is the internal port, and this is the port that we need to use to actually access the service externally. So let's move over to Insomnia again, and I'm going to create another top level folder, this time for our Kubernetes environment. So a new folder, and I'm just going to call it K8s. Okay, so we've got one for local development, one for Docker, and one for K8s now. And then we're going to create another folder here for platforms, platform. Let's just keep it consistent. Platform service, let's rename that. Rename. Probably being a little bit pedantic, but want to keep it consistent, otherwise it can get a bit confusing. So platform service, and then we're just going to duplicate this one here. Okay, and we'll move it under here. But unlike, we don't want to use 8080, we want to use that other port that Kubernetes has given us or generated for us, so it's here. So if we just copy that, try that again, so it's 30, 40, 70. And we come over here and put that in here. And yeah, it looks right. We query, there we go. We have access to our service running in Kubernetes, which I think is very, very cool. So give yourself a round of applause for that. We're making very, very good progress. So basically that is, well, that's not it. Obviously we still have a long way to go, but let's refer back to our diagram to kind of check on progress. So we've now done this, that's fantastic. So really the next thing we want to do in the next section, we're going to concentrate, we're going to go back into writing .NET C# code, and we're going to construct up our command service, and then we're going to do a very similar thing and deploy it in here, and then we're going to get them talking to each other, and then it starts to become much more interesting, because then we're really going into microservices concepts. We talk about how these services can talk to each other synchronously or synchronously or both. So yes. Next section we're going to move on to is to construct our command service. All right, so now what we're going to come on to do is create our command service in our kind of solution area. So back over in our, it's not really a project anymore, back over in our solution, just make sure you stop any running services.
And let's close this stuff down as well. All right, so make sure that you are in the kind of top level of the solution. In fact, we're going to need a command line. So in the command line, just do a directory listing to make sure that you're in the top level solution area. You can see the platform service in K8's folders. And we're going to scaffold up a new service or commands service. So .NET new, so web API, and the name is command service. Hit enter and that should go away and scaffold up our command service. Fantastic, and it appears here in our directory listing. So next thing we want to do, I'm just going to get rid of this, is bring up your CS proj file so you can see what package dependencies or package references we have in here, and we're going to add some more in a very similar way as we did with our other service or platform service. So .NET add package, and the first one, again I'm going to just copy the first one. In fact, I'll probably copy most of them over. Save you watch me typing, is Automapper. We're of course going to use Automapper here as well, so I think I must have done something wrong. Oh yes. So what I haven't done is change in to the project that we want to be working with. So cd into command service. There we go. So what it was complaining about there was I was trying to add a package reference and it's complaining that there was no project file basically. So there we go, rookie mistake. And there we go. So we've got Automapper added into our CS proj file now. Fantastic. So we're going to add a few package references here. I'm not going to add all the packages that we need. I'll add the ones that we're going to need in the kind of near future. The ones that we'll work with a bit later down the line, I'll pull them in a bit later. So the next one is add package Microsoft Entity Framework Core. And just make sure it's added into the CS proj file. I'll do up key, and then we need exactly the same, but this time design. And again, this is mostly the same. In fact, it's exactly the same as the platform service as well. Now, I did debate whether to just, skip this, not skip the section, but, not go through all the setup again. But I think it's good practice for you to go through the setup again anyway, and it kind of embeds what we need to do. And it is only one other service, so I think it's probably the right approach. And then we're going to add in memory. Now, as I said previously, I'm not going to work with a SQL Server database for this service, simply just to kind of reduce time a little bit. Working with an in-memory database is fine for the video. If you are moving into a more production environment, yes, you would use SQL Server. But for the moment, I'm just going to use in-memory. That's all. And that's it for the moment. We had the swashbuckle package reference in there. Again, that's for Open API. If I remember, we'll take a quick look at that. But that's it for now. So that's our package references done. Our project is scaffolded up. What I'll probably just do is just remove the stuff that we don't want. So the weather forecast service, we don't want that. And into our controller, we'll take out our controller as well. Whoops, we'll take that out as well. And we'll delete that. Now the other thing we'll actually do is over in properties, in launch settings JSON, if we spin this up, and we will actually spin this up locally, it's using the same ports as our command service 5000 and 5001. And so when we're doing some testing, before we deploy to Kubernetes or even package up in Docker, I'm going to run them both up locally and have them running at the same time, just using the .NET command line. And so obviously we'll get an error if they're both trying to launch on the same port. So I'm just going to change the command service ports, local ports, to 6000. All right, and what we might do, just to make sure it's all wired up correctly, is just do a .NET run, because you never know, there might be some little gremlin in the system that we didn't think about. And that all looks fine, and it's running on port 6000, 6001. It's not going to do much at the moment, because we've taken out our controller and we don't have any models or anything. All right, so we'll close that down. Now in the next section, what we're going to do, what I really want to focus in on, is we're going to create a controller first. We're not going to create models or anything like that. I'm just going to create a very simple controller with a very simple post action endpoint in it. And the point of that is I want to just get our two services talking to each other. That's really the next part of the video. We will eventually come back and we'll add models and we'll add all that kind of stuff in here. But for the moment, all I'm really wanting to do is get our two services talking synchronously to each other using HTTP. We'll do that locally and then we'll do it in Kubernetes. Okay, so that's really the path we're taking next. So in the next section, we're going to create a controller with one action in it that's going to receive a post request from somewhere else. And then we're going to get our platform service to talk to it in a synchronous way. All right, so we'll do that next. All right, so we're going to create a controller in our commands service, simply at this point, just to receive a post request from something else. In this case, it'll be our platform service, just sending something over to us, really just to test synchronous HTTP communications between the services locally, and then we'll do it in Kubernetes. All right, so back over here, I'm just going to close this down, close down the command line and close down launch settings JSON. And over in our command service, if you right click the controllers folder and new file, we're going to create a controller. Now this service is going to end up with two controllers. It's going to end up with a commands controller, as you'd probably expect, but it's also going to have a platforms controller. Why? Basically because this service is going to work with two models. It's going to work with commands and it's going to work with platforms. And the way I've architected this service, basically the platform is really the parent resource of the command resource. So if you think about it logically, you're going to have a list of commands like, you know, .NET run, .NET build. There'll be loads of those and they will relate just to one other resource, the platform. Okay, so when we are using REST, as we are here, to create resources such as platforms and commands, what we should really do is split those out into two different controller actions. So we'll have a controller to deal with our platform stuff, very similar to a platform service, and we'll have a controller to deal with our command creation stuff. You'll see how that unfolds a bit later, and I've got a whole section on sort of multi-model REST APIs. But for the moment, again, I just want to focus on getting some comms between the two services. So it might be sound a bit counterintuitive, but the first controller we're going to put in our command service is our platforms controller. Okay, so in controllers, create a file, platforms controller .cs. All right, fantastic. Now let's keep going, but I just want to call your attention to the fact that we are running VS Code with these three projects in here now, and that it can sometimes behave a little bit strangely, but let's see how we go. So namespace this time is going to be commands. Yeah, I think it's doing it already. Commands service. Yeah, and so we're not really getting auto completion at the moment. If you sort of see what's happening, usually if I started typing command service, I would get prompted with the full name of the, of the service for our namespace. But let's, it's very evident how reliant I am on it because I'm so used to that pattern. Let's keep going. Command service .controllers. Okay. And we'll just bring that onto the next line. Okay, and it's a public class. So public class platforms controller. And we're going to inherit from controller base. And we don't have that namespace, so control period. Now, this is what I'm talking about here. I'm doing control period to bring in my list of code suggestions, and nothing is happening, okay? And the reason for that, or I believe the reason for that, is because we're running VS Code and we're now having it hosting multiple projects. So the kind of IntelliSense stuff appears not to really like that. So what we're probably going to have to do is close down our VS Code session running all these projects and reopen it just with command service. And I'm fairly sure then we'll get our code suggestions. So let me just save that off for the moment. Kill this. Actually, I won't kill it. I'll just bring up a command prompt, and then we'll come up a level, do a directory listing so we can see all our projects, and I'm just going to open code recursively, and I'm just going to open command service itself. Let's do that. Okay, fantastic. And if we come back over to our controller, there we go, it should start complaining, and I'm fairly sure if I put my cursor in there and do a control period, I will get my code suggestions again. So it's just something I've found. I'm not sure if there's any other way around it. There probably is, but for the moment, I'm fine with just running an individual project in our VS Code session. All right, so public class, platforms controller, inheriting from controller base. The next thing we want to do is decorate our class with API controller. As before, it gives us some nice default behaviors, and we're going to create a route again. Okay, so from memory from last time, API, and then you can either put in, not curly brackets, square brackets, you can put in controller. Okay, now you might see a problem straight away here, because we're going to have a route to something called API/platforms. We're also going to have that in our other controller as well. They may go, well, that's not a problem because the rest of the URL is going to be completely different. The IP address or the domain name is going to be different. Correct, that's fine. So we could leave this like this for the moment. However, when we come on to using our API gateway, things get a little bit more complex. So I'm just going to call that out now. I'm going to leave it like that at the moment. This will still work at the moment, but going forward, we are going to have to change this slightly to reflect that this is a slightly different platforms controller from the platforms controller in our other service. In fact, I'm going to put it in now, okay? Because if I forget when we run into issues, it might become a bit problematic. So what I'm going to do, and again, when we move through the rest of the video, this is all kind of hidden. Once we hide all this stuff behind an API gateway, this stuff is hidden. So you're not going to have these horrible URLs that you're going to have to deal with. But just for future proofing, I'm going to put this in. So all I'm doing here is the root is API, and then I'm going to specify that this C really is for our commands. This could be anything, by the way. I'm just putting C in. So API/C to denote our commands service, and then the name of the controller. It'll become clearer later on when we move on to the gateway stuff. So bear with me on that. So that's our route. Fantastic. I'm going to create a shell constructor just so it's there, but we're not really going to put anything into it yet. Now we will eventually, like we did with the platform service, inject in automapper and a repository, but we're not doing that yet. Again, in this section, all we're interested in doing is getting an action up and running. All right, so we'll leave a constructor like that for the moment. And then we're going to create our first test action. So it's public, action result. And I'm just going to call it test inbound. Connection. Okay, and it's not going to accept anything really. And all we're going to do is just do a console write line, keep it really simple, bring in the namespace for console using system. Console write line, and I'm just going to put something like inbound post at the commands service. Okay, so all we're doing. So we hit this action, we're going to get this printed out to the screen, and I just need to make this decorated with HTTP post. And then finally, you do need to return something back as it's an action result, so we'll just return OK. And I'll put something in here, I don't know, inbound test OK from platforms controller. Quite a few spelling mistakes in there. All right, fantastic. So that probably looks a little bit convoluted. I'll put the trailing semicolon in there, and maybe some of the stuff in here going, don't quite follow that. That's okay, don't worry, it will become a lot clearer later on. So what I want to do now is just test this, okay? I'm going to test it from Insomnia just to make sure everything's wired up correctly and it's working okay. So into the terminal, make sure you're in command service, we'll do a .NET run. I don't think I'm forgetting anything, but we'll find out. And it should be running again on port 6000. Fantastic. So let's bring up Insomnia, and we're going to close all that down, and we're going to come over to our local development environment because that's what we're running in. We're going to create a folder under here, new folder, and we're going to call it command service. And we're going to create a new request. It's going to be a post request. We'll select JSON, and we might pass some JSON over eventually, and we're just going to call this test inbound connection. Okay, create. Fantastic. Then what I might do is just come in here, and I'm just going to copy this. Make sure I copy it all. And I'm going to paste it in here. Make that a little bit bigger so you can see it. Now, a couple of things here. The port's going to be different, so it's going to be port 6000, and as per our route, it's going to be API/C platforms. Okay, so back over in our controller, you'll remember, this is the route to this controller. Okay, so API/C, and it'll be platforms, because we're in our platforms controller. All right, so again, screen's running at quite high magnification, so I'm just going to click send. You get 200 OK, and we get the response back, inbound test from our platforms controller, which looks good. And if we come back over to our running service, you can see that we got this message printed on screen. Cool, so very simple, but really just setting this up to establish that we have an endpoint in our command service. What we need to do now is create a method of calling this from our platform service, so we have that degree of, so we can establish some communication service to service. We'll run that both locally, and then we'll deploy it into Kubernetes. So we'll move back over now to our platform service and write up what we're going to call a synchronous client, effectively, synchronous HTTP client. So we'll do that next. All right, now actually, before we move on to doing any coding, I do appreciate I've been talking about synchronous messaging and asynchronous messaging, and you might be going, what's this guy talking about? So yes, I think it's a good time to talk about this now. I was going to leave it till a bit later when we came on to talking about message buses, but I think since we're starting to do some messaging now, I think it's a good place to actually put these slides in. So yeah, let's talk about synchronous and asynchronous messaging. So what is synchronous messaging? In short, it's basically talking about a request response cycle type setup. Okay, so as a client, I'm going to make a request to our HTTP endpoint in this case, and I'm going to sit there, I'm going to wait until it responds back. Okay, so the requester will wait for a response. This is probably going into maybe a bit too much detail at this stage, but generally speaking, and it's probably quite a controversial statement, and I'm probably going to get lots of hate mail for this one, but generally speaking, services such as our command service and our platform services, when they're servicing requests to external clients such as a web application or Insomnia, those type of external facing services are synchronous. Okay, that's a very common pattern. When you're talking about service to service communication, i.e. within our cluster, for example, and it's just services talking to each other, you can use synchronous communication for sure, and we're going to do that. But for the most part, we, in this video anyway, are going to be using asynchronous communication, and I'll come on to what that is in a bit. That might be a bit of a controversial statement, but yes, for the most part, externally facing services are definitely synchronous. They don't tend to be asynchronous. That's less controversial, all right? Synchronous services usually need to know about each other. So as a requester, I need to go and know exactly, explicitly, I need to request that service for some reason, and I need to know where it is. Now, I put usually in brackets because there are things like service discovery and service meshes and all that kind of stuff where you can maybe have that kind of automatic service type discovery. We're not covering that here today. So for the most part, what I'm saying is if you're making a synchronous request to an endpoint, you need to know where that endpoint is. You may go, well, why is that? Why is there an issue with that? Well, it becomes a bit of a management overhead. If your service is calling another 10 other services, it needs to know exactly where all those 10 other services are in order to call them. And it becomes a bit cumbersome. We're going to be using two forms of synchronous messaging today, HTTP, which we'll come on to doing next, and gRPC. All right. Now, this bit I really wanted to put in because it can get a bit confusing. So I've just said HTTP is a synchronous messaging construct. Cool, and it is, right? So I'm not retracting that. A very good question, it's a question I had initially as well, was hang on, wait a minute, if I've written a controller, which we have done, and I've got some action results in there, I can mark those action results as async. Doesn't that make it an asynchronous messaging construct then? The answer to that is no. and I'll tell you why. So from a messaging perspective, as you can see on screen, say we did tag one of our action results as asynchronous. From a messaging perspective, the method is still synchronous. Any client making a request to that endpoint still has to wait for a response, okay? The async stuff is really all to do with the way that in service manages its threads internally. From a client perspective, from a messaging perspective, anybody requesting that service still has to wait for a response. So it's still synchronous messaging. Just to clarify, async in this context, the C# language context, means that the action will not wait for a long-running operation. So say that action result is doing some lengthy database dip, or maybe even calling another service. If it's long-running, what that async keyword means is it's not going to wait, it's not going to maintain hold of its thread while that long-running operation executes. It's going to return the thread back to the thread pool. Okay, so yes, it says here it will hand its thread back to the thread pool where it can be reused. When the long-running operation finishes, it will reacquire a thread and complete, and then respond back to the requester. So all this time, the requester in this scenario has still been sat there waiting for this service to respond back. This whole async construct is purely about thread management internally for that service. Messaging perspective, it's still synchronous though. So yes, as it says there, async in this context is really about thread exhaustion. The requester still has to wait. The call is still synchronous. Okay, so async in this context is about C# language, thread management, nothing to do with messaging. HTTP is still a synchronous, by and large, messaging construct. All right. So synchronous messaging between services can and does occur, and we're going to implement this. So as I said, this is all coming back to this. Do services talk synchronously to each other? We are going to do this. However, it does tend to pair services. It does tend to couple them a little bit, creating a dependency. Now again, in the microservices world, one of the kind of tenets is that you want to try and decouple where possible. You don't want lots of chatty communication between services. They're going to have to talk to each other, and there's a bit of a paradox here, but for the most part, you don't want lots of inter-service communication, and you certainly don't want it in a synchronous fashion, I don't think. And it could lead to something called, additionally, it could lead to something called dependency chain. So let's look at this diagram here. Service A makes a synchronous call to service B. Service B then has to make calls to services C and D, and service D then has to make a synchronous call to service E. So you can imagine if there's delays between any of those request response cycles, or if one even fails, what's going to happen. Not a fantastic result. And service A is probably going to be sitting there waiting for a long time. You also have this horrible kind of, the name says all dependency chain, where each service needs to know exactly what other service to call. It starts to get a bit cumbersome. You might have heard the term spaghetti programming, maybe not fully applicable in this state, but you get the idea. It becomes a bit of a mess, okay? But nonetheless, we are going to implement it to begin with, and there are scenarios where it's probably the better pattern to use as opposed to using an asynchronous event-based pattern. And we're going to implement that with gRPC a bit later. So I'm not saying you don't use synchronous communication, I'm just saying you've got to, as a developer, you've got to make that decision about which is the best to use from a service-to-service perspective. All right, so asynchronous messaging. There is no request-response cycle. The requester does not wait. Sounds good, doesn't it? It's more of an event model, and for example, a publish-subscribe type model. Typically used between services, again, might be a controversial statement. There's some people out there that would probably disagree with that, but this is my video and this is what I'm saying, so go with it. Event bus is often used, and again, we're going to be using RabbitMQ much later down the path. We'll introduce RabbitMQ. And services don't really need to know about each other. They just need to know about the bus. So the idea is, as a requester, I just need to talk to the message bus and put something onto the message bus and go, here you go, here's something that other services need to know about, or here's some information that I potentially need. And I just put that onto the message bus, and the message bus sends out these events to any other services that are subscribed to those events on the message bus. Those other services will receive an event, go, oh, okay, I've got this new event, and then will respond back onto the event bus in that kind of fashion. So it's event driven. The event bus kind of sits as an intermediary between services, and it's publish, subscribe type model, event-driven model, and we're going to go into that quite a bit in this video. It does, though, introduce its own range of complexities, and it is actually much more complex than a synchronous request response cycle. It does introduce a lot of other things, that make it more complex. It's not a magic bullet by any means. So then the final slide in this section, and it's a question I wanted to surface here, is, isn't the message bus a monolith? It's this big thing that all these other services are dependent on. To some extent, yes. And it's the same kind of conversation you'll have about API gateways. Is an API gateway basically a monolith? Again, to some extent, yes. But focusing in on the message bus, is it a monolith? Yes, to some extent, yes. Internal comms, if services are reliant on the message bus, internal comms between services would stop working if the message bus went down. However, if you've designed your microservices appropriately, those services should be autonomous enough that they can still deal with external traffic, they can still deal with requests to them and be able to deal with them to some extent, even if they cannot talk to other services internally. So yeah, services will typically still be able to operate and work externally, with some caveats, of course. The message bus, therefore, because it is so important, should be treated as a first-class citizen, similar to the network, physical storage, power, any of that stuff. And so typically, when you're setting up a message bus in a production environment, you'd set it up in a clustered fashion. You would have fault tolerance, you'd have multiple instances all talking to each other, so if one goes down, it's not an issue. And again, that's how RabbitMQ themselves recommend you set up RabbitMQ in Kubernetes using this cluster type approach. We're not going to do that here. It's a bit too complex for this video. It's just an introduction video. So we're just going to set up a single instance of RabbitMQ for our purposes. But generally speaking, in a production environment, you would have this cluster. The other thing I put there is you'd also typically have, a degree of persistence. So if your cluster dies and then it restarts again, it's not lost all the messages that it had in the queue. It should have some degree of the ability to retrieve messages it had in its queue from some persistence layer. That being said, services should also implement some kind of retry policy. So say the message bus goes down, you don't want to just fire messages onto it, and then if the message bus is gone, you've lost that event. The services should be intelligent enough to retry, keep those events queued up and retry when the message bus comes back up. So something you'll hear about often in the microservices world is you aim for smart services. Your endpoint should be intelligent, the pipes should be relatively simple, or stupid, as I put there. Okay, so they're really just there as a transport to get one event from one service to the other. All right. So with that, again, I just wanted to introduce you to this concept of synchronous messaging. We're going to be talking about it a lot, and asynchronous messaging. We're going to be talking about it a lot. When we come on to asynchronous messaging and RabbitMQ, we'll do a full section on that a bit later. But for now, we're going to move back over to our platform service and implement a synchronous client that will allow us to talk to our command service. So we'll do that next. All right, so back over in our command service. We're not actually going to work in our command service now. We've got everything we need in here for the moment. So I'm just going to close down the running service. Now, I'm going to leave our command service running in this instance of VS Code, and I'm going to bring up a separate instance, a new window, for our platform service, because we're going to be working in there now. So in our new instance of VS Code, I'm going to move into my working directory, season 4, and change into episode 3. And I'll do a quick directory listing to make sure I can see a platform service. And then we're just going to open that in this instance. Cool. All right. So we have our platform service up and running now. So yeah, what we're going to do is create a HTTP client effectively. It's going to issue a post message to our command service. Now this is just a test really, we're not really going to implement too much functionality here, but the idea would be that if we created a new platform in the platform service, that we would want to let our command service know about it, because our command service is somewhat reliant on platform information. And one way we could do that is by sending a HTTP post payload over to our command service, and it could then take that and do with it what it wants. We're going to properly implement that using a message bus type construct. So using an event publisher subscribe type model, we're going to properly implement it doing that. Here, we're not going to fully implement it. All I really want to do here is just make sure that we've got comms working between the two endpoints
more especially when we come to putting it into Kubernetes. This is more actually a Kubernetes thing, really just setting up the networking between our services. And I'm doing this just to test that, help test that. Nonetheless, it's still a valid use case, and we want to make sure that it's all working. So back in our platform service, we're going to create a new folder for our synchronous data services. So new folder, and I'm going to call it sync data services. And we're eventually going to end up with two types of synchronous data service, HTTP that we're doing now and gRPC. But we're going to just focus on HTTP for the moment. So new folder, HTTP. I'll make sure I capitalize H. All right. Now we're going to make use of something called a HTTP client to make the request. And moreover, we're going to make use of something called a HTTP client factory to basically give us a HTTP client. And then I've done videos on this before. The main reason we're using HTTP client factory is if you're making multiple requests using HTTP clients, you should be using a factory to do that for you, because it just manages connection safety and all that sort of stuff, and you don't end up with, again, connection exhaustion and all that sort of stuff. So we're going to be using a HTTP client factory, but if you follow along with the code, it should be relatively straightforward. So the first thing we're going to create is an interface, because we are going to use constructor dependency injection, and we're going to inject this client into various places, namely our controller. So we want to allow constructor dependency injection from that perspective. So new file, and we're going to call it I command data client.cs. And then we're going to define namespace, platform service, sync data services.http. Fantastic. And it's just a public interface called I command data client. And we're just going to have one method signature. It's going to be asynchronous, and you'll see why in a moment. So we'll have to bring in the namespace for task in a second. And we're just going to call this send platform to command. Now, we're not really going to do anything with this, but I thought just to kind of make it a bit more of a realistic example, if we come over to our DTOs, the idea is we want to send over a platform that we have created. And we have two DTOs here. We have our platform read DTO with all this information in it, and we have a platform create DTO with this information in it. Now, I'm thinking in this case, when we send a platform over to our command service, we probably actually want to include the ID, our ID, because we probably want to give it a reference, a unique reference to the platform that we've created, so it has that. So I'm going to use the platform read DTO as the message that we pass over, okay? So in here, I'm going to say platform read DTO, and we'll just call that plat. So we're going to bring in a few namespaces here, so control period to bring in platform service DTOs, and we need to bring in threading for this. Okay, great. So that's our interface created. So I'm just going to come on now and create the concrete class. So again, within the HTTP folder, new file, and I'm just going to call this HTTP command data client.cs. Okay, specify the namespace, platform service, sync data services, and as we've typed this in before, you can see it's remembered it, which is cool. And then it's just a public class called HTTP. And I realize I've just spelled that wrong, so let me just rename that. Command data client, yep, so HTTP command data client, and we're going to implement the I command data client. So we'll do a control period, implement interface. Fantastic. Now, before we actually come on and implement this method here, what I want to do is make use of this HTTP client factory. So in order to do that, we use, once again, constructor dependency injection here. So we're going to create a constructor for our class, and into it, we're going to inject a HTTP client. And you'll see how this all ties together when we register this service in our startup class. And we're just going to call that HTTP client. So into here, we're going to get this HTTP client injected, but we do need to bring in the namespace of using system.net
HTTP. Fantastic. And again, we need to create a private instance. So I'm going to call underscore HTTP client is equal to HTTP client. And in here, control period to generate a read-only field that we can use throughout the rest of our service, or service method. Put it in here, use it in here. Okay, so let's just save that for the moment. And now we're going to come down and actually implement our send platform to command synchronous call. So the first thing I want to do is create a payload effectively that would contain our platform read DTO or information. So I'm going to do a var, call it HTTP content, and it'll be a new string content object. Open parenthesis, I'll just put in the semicolon. And the first thing I'm going to do is I'm going to serialize this object, this platform read DTO. So I'm going to use JSON serializer. I spelled that correct. No, I don't spelt it correct. Serializer. I think that's right. Yeah, so using system text JSON. Now you can see you get two choices here. You could use the older Newtonsoft JSON library. I'm using the Microsoft library moving forward now. Okay, and we're just going to serialize the platform object so we can send it over the wire, basically. All right, and in the encoding, bring in the namespace for that, should be system text, there we go, is going to be UTF-8. And then finally, we just need to specify the media type, which is going to be application JSON. Okay, I'm going to bring that back up onto this line here. Okay, so this string content object is something we're going to send over with our post request. Okay, and it's still complaining because we're not really returning anything as yet. And then we're going to basically make a post async request to our client. So I'm going to do var response equals await. Use our HTTP client, post async, and I'm just going to do a control B to get rid of our sidebar. You can see what's happening. And here we don't have a problem at all because we will solve it, of course, but we need to know where, and again, this is talking about kind of your pairing services to one another. We need to know where to send this post request to. Now we can just hard code the URI of our service in here. Okay, but that's not a particularly elegant solution. So what I want to do is I want to move in and put this type of stuff into config. Okay, but for the moment, let's just hard code it, and we will eventually come back and put it into config so that it's not hard coded, which is never a great idea. So basically what we want to do, let's come back over to Insomnia. And when we tested our inbound connection in our local environment, this is the URI or URL that we want to send this to. So we'll just copy this in for the moment. Again, I just want to get this up and running and working, but we'll circle back and put this into config. Okay, so paste that in there, and then we need to supply the HTTP content along with this as well. And it's complaining, the await operator, okay, so we need to put in async up here. There we go, and that should resolve that. So basically it was complaining that we couldn't call an await method when this method signature wasn't asynchronous itself. Okay, so we're going to post to our endpoint and we're going to provide that HTTP content. Cool, and then all we want to do then is just check that we get a successful or otherwise response back. So if response is success code, then we'll do a console write line. Bring in the namespace using system, write line, and we'll just say sync post to command service was okay. Otherwise, console write line. And I might just copy this message here. And we'll say it was not okay. All All right, fantastic. So let's save that off. Okay, so we've still got a couple of things to do. We want to bring in configuration rather than hard-coded strings. So what we can do actually is up here in our constructor, where we're injecting in a HTTP client, we can also inject iConfiguration. Configuration, and we'll just call that configuration. Okay, we'll bring in the namespace for that. Now, iConfiguration is one of those lovely objects that gets injected everywhere, basically, or can be injected everywhere, so you don't really have to do too much setup there. The other thing to be really careful of, and I've made this mistake, is that bring in the right namespace for iConfiguration, because Automapper also has that too. So make sure it's the Microsoft extensions configuration that you bring up at the top, okay? And then we will set up a private field, so call it _configuration and make it equal to configuration. And then control period, generate a read-only field. There we go. And we can use this configuration now to inject this in from a config file. So I'm going to copy this and I'm going to do a control B, and we're going to come over to our configuration file. So we have our app settings development JSON configuration file, which seems like a good place in which to put our config for our endpoint from a development perspective. So what I'm going to do is I'm going to come over to here and into our app settings.development JSON. I'm going to create a new parameter in here, and I'm just going to call it command service. And the value, I'm actually just going to make it the kind of base URL for our command service, so we know where to get to it. So we'll save that off in here, and we'll come back to our command service. I'll do a control B to bring this down, and what I'm going to do is I'm going to take this out, and I'm going to make use of string interpolation to inject in that part of our URI into our endpoint here. Now you could put the whole thing, to be honest with you. You could actually put the whole thing in. I'm just putting the server URI, but you could put the whole path in if you wanted, which is entirely up to you. And I'm just going to make use of configuration. So basically, what we get injected in here, configuration, and then just reference the setting that we put in here, which was command service. So just copy that and put that in here. And make sure you get the forward slash. So basically, this thing here, all the way up to here, is basically going to be HTTP localhost port 6000, and then the rest of the URI. Now again, you could replace the whole thing if you wanted in here with that. Entirely up to you. In fact, do you know what? Let's do that, because it doesn't really make sense, does it, to just have that little bit. So let's just put that in here like that. That makes more sense, doesn't it? Yeah. Okay, so basically we're just going to put the whole thing in. All right, so that should work now. Actually, no, it won't. There's one thing that we still need to do, and I'll just take this out. I don't know how that got in there, so let's save that off. Now, because we're using this HTTP client factory ultimately, or we're getting a HTTP client injected in, we need to make use of a HTTP client factory in order to do that. So this is the last bit of this section. It has been a bit longer than I had intended, so I do apologize, but control B, and back over in our startup class, what we want to do in our configure services method is under our repository registration, we're going to make use of our services collection again, and this is where the HTTP client factory gets used. So we're going to add HTTP client, okay? And we're going to specify the interface. So in this case, it's going to be I command data client. So when we ask for an I command data client, we're going to give it a HTTP command data client. So this is us basically, this add HTTP client is making use of a client factory. And so when, let me just bring in the namespaces for these, and both should resolve them as they're in the same namespace. That's correct. So they have resolved. So back over here, when I'll do a control B. When our class constructor gets called, we're going to get a HTTP client injected in here that's going to be managed by a HTTP client factory. All right, so that was quite a long section. We need to test this now, so we'll do that in the next video, just to might have a cup of tea now, and then come back and we'll test this and make sure, test it locally, make sure that when we make use of this, and we'll have to put this into our controller in a second, we'll do that in the next video, when we call this service, we can actually send a message down to our command service, but we'll do that in the next video. All right, so still in our platform service, what we want to do is we've created our synchronous client, our HTTP synchronous client here. What we want to do is we actually want to be able to use it somewhere. And so where are we going to use it? Where does it make sense to use it? Well, it probably makes sense to use it from our platform's controller. So when somebody runs a HTTP post and we create a platform in our platform service, at that point we want to make a synchronous call, or do we, to our command service to make them aware, hey, we've just created a new command. All right, so we're going to put that code in here, and then we're going to test it. So just do a control B, just to give us a bit more breathing space. So the first thing we need to do is actually inject in an instance of our command data client into our platform's controller so we can use it. So I'm just going to take a new line for our injected parameters because it's going to get a bit long. So we'll still keep platform repo, we'll still keep imapper, but now what we want to inject in is an I command data client, and we'll just bring in the namespace for that. So using platform services, sync data services HTTP, that's cool. And we'll just call that underscore command data client. And as usual, we need to create a private instance of it. So I'm going to call it underscore command data client equals command data client. There we go. And, oh, hang on. I should just create that. Yeah, there we go. That's right. There we go, that's better. So yeah, make sure the one that you're injecting has not got the underscore, and the one that we are creating now has got the underscore. Okay, so generate a read-only field. And again, this pattern should be very, very familiar to you now. And again, coming back over to our startup class, because we've registered this here, we have this available to us in here as well. Okay, so we just come down to our post endpoint. And just before we return back with our created it route statement, I'm going to make a call to platform service at this point. Now, because things could potentially or conceivably go wrong, I'm going to use a try catch block because we don't want some horrific exception if that endpoint is down, for example. So I'm going to make use of the await keyword. I'm going to make use of our command data client. I'm going to send platform to command, and I'm going to pass in platform read DTO that we've got here. Okay, and that should be sufficient for this. And it's going to complain here, but we'll fix it up basically because this is not an asynchronous endpoint. And again, I will stress async in this context has nothing to do with asynchronous messaging. But before we do that, we'll just catch any exceptions. We'll call it EX, and then we'll just do a console write line with something of the nature of and we'll use string interpolation, so we'll put $sign before the double quotes, and we'll say could not send synchronously. And there may be reasons for that. I don't think I've spelled that correctly. Have asynchronously. That's right. Doesn't really matter, but for those of you who hate spelling mistakes, it probably is quite annoying if it is wrong. And then we're going to just pass in the message that we get from any exception. Okay, so hopefully this makes sense. So we'll try and send, use our data client to send a platform read DTO to our platform service. If it fails, we'll catch an exception. Now again, this is complaining because it's saying there is no await operator, but that's okay. So we can just put that in here, make it synchronous. But in order to do that, we have to specify it's a task really that's being returned. So task, and then close that off like that, and that should be okay. Not await, async. Okay.
There you go. So async, await. And I don't think we have the threading namespace, so we'll bring in using system threading tasks. So this has now made this action result an asynchronous action result, because potentially this command here could be long running. But again, to labour the point, from a calling perspective, it's still asynchronous messaging. So let's save that off. Let's bring up our command line. Let's do a .NET build. Looking good. We'll do a .NET run. And again, just to be, super sort of pedantic, you can see here that, where it should say it here, it usually says it. There we go. The hosting environment is development, okay? So because the hosting environment is development, it will make use of our app settings.development JSON file and pull in the right config for our command service endpoint. And actually, what we might do, I'm just going to stop running, and what I might do is up here in our startup class, what I might do is in configure services, I might just do a bit of an output just to say console write line, and we'll just say, just so we can see this printed to the screen, command service endpoint, and we will make use of our configuration object called configuration in this case. And we'll just specify this. So we'll have this printed out to screen, and because we'll probably do this quite a lot because we're going to be moving between different environments, so it's probably worth just printing out to our console what it thinks the endpoint is. So let's just start that again. There we go. So you saw there what it thought the command service endpoint is. There we go. So this is what it thinks the endpoint is, and indeed that is exactly what we should be using. Seeded data, all good. So that's our platform service up and running. Let's move back to our command service. Let's make sure that's running. Fantastic. And then what we're going to do is we're going to make a platform create request in our platform service, which should then call our command service. All right, so moment of truth. So bring up Insomnia once again. We're in our local development environment and we want to create a platform in our platform service. Okay, so let me just send this over. Looks like it created it. And we'll come over to our messaging, and you can see here within our command service we have an inbound post from our command service. Fantastic. And we come back over to our platform service, we have a message saying the synchronous post to our command service was okay. So that's all working rather nicely. But what I'm going to do, just to illustrate a point, I'm going to come back to our command service and I'm going to stop it. I'm going to kill it. Okay, so that endpoint is no longer there. And I'm going to do the same thing again, and we're going to see what happens. Okay, so we'll create the same thing again. So let's just click send. You can see it's taking time. Still comes back okay because it created the service okay, but you saw that took 2 or 3 seconds. Why did it take 2 or 3 seconds? Well, basically, if we come back to our platform service, you can see we could not send synchronously, no connection was made, blah, 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 which totally makes sense. But you saw how, as a consumer, we were waiting for that, okay? We're waiting for that response to come back. And you imagine there's a chain of those type of things or anything like that. Not a great experience. Nonetheless, we have achieved what we wanted to achieve. And just to recap, it's been quite a long section. We have created a test endpoint in our command service, and we've created a synchronous data client in our platform service that will call this test service in our command service synchronously. Cool, so we've established that that works. What we need to do now is put our platform service into Kubernetes and then wire up these two services using cluster IP addresses. So we're going to do that next. All right, so let's just do a quick sense check again of where we're at and what we've done. So we have our platform service running in Kubernetes, and we have our node port set up. We do not yet have our command service running in Kubernetes, but we have it running locally, and we had established connectivity between the two. That's cool. So in this section, what we want to do is, first of all, get our command service up and running in Kubernetes, and then we're going to create cluster IPs for each of our pods so they can talk to each other. So really the first thing we need to do, the first step of getting our command service into Kubernetes is packaging it as a Docker image and pushing it up to Docker Hub. So we're going to do that now. So let's just make sure we're in the right space. We want to be in our commands service. So we're here, so we're in commands service, and you can see here we're in the right space. So do a quick clear of the screen, and what we want to do is create a Docker file. So in the root of our commands service project, we're going to right click, new file, and we're going to create a Docker file, as we did before with our platform service. Now, all I'm going to do is come back over to our platform service and copy out the config from our platform service Docker file, because it's basically effectively exactly the same, bar one small change. All right, and that's down here, that's the entry point. So rather than it being platform service DLL, it's going to be command service DLL. Now let's just double check. In the bin folder, we want to make sure that the DLL commands service is matched here. It's exactly the same thing. I actually made a mistake in one of the other recordings of this video, and I got this name wrong and it caused all sorts of issues. So just make sure that you have the right entry point, and we'll save that off. Okay, and then as before, we'll do a Docker build, and we'll tag it with your Docker Hub ID, and then the name of the service, command service. Don't forget the build context at the end. All right, so we'll go away and build that. Should be relatively quick. Fantastic, and then we'll push it up to Docker Hub. So get rid of the build context, get rid of the T, and we'll just type in push, and this will push this up to Docker Hub, so that when we create our K8's deployment for our command service, it has an image to go away and pull down. So we'll just let Docker do its thing and push that image up, and then we'll come back and we'll actually test and make sure that our Docker image is actually running as well. I probably should have done that before I pushed it, but we'll wait, we'll let the push finish, and then we'll test and make sure that it actually runs up okay. Now interestingly, you can see here that it's saying layer already exists. So because it is aware of layers for this image elsewhere, it doesn't have to push the whole thing back up. Okay, so that's pushed up. Now before we do anything else, I should have done this before I pushed it. We're going to do a Docker run. So Docker run, we'll specify an external port mapping to an internal port mapping, which you should be familiar with now. I'm not going to run it in detached mode because I actually want to see the output when we run it. So just the name of the service. Okay, so binary thistle command service. Let's run that up. It's cool. So it's run up okay. It's started on port 80. We're not getting any errors, so that all looks pretty good to me. So what we might do is come over into here, and we can see that we have a command service running. So I'm just going to stop that from here. And we get our command prompt back. So that all looks good. So in the next section, what we're going to do is we're going to update our platform's deployment file to include a cluster IP service, and we're going to create an entirely new commands deployment file that also includes a cluster IP service. So we'll do that in the next section. All right, so let's come over to our K8's project. And here we have our existing platforms deployment. Now that's not actually going to change. That's staying exactly the same. But what I do want to do is come underneath here and add in a definition for our cluster IP service. Now you could put this into a separate file if you want. I like to keep it in this instance in the same file, as the two things are really very closely related. All right, so we specify an API version, and this time it's v1. So this will look very similar to the node port stuff that we did a bit earlier. The kind is a service, and then metadata is basically the name of our service effectively. So we'll specify name, and we're going to call this platforms cluster IP service. These names get quite long, so you've got to really check your typing. And I guarantee you will make a typo at some point throughout this course. So just be really, really meticulous with your spacing and with the, the naming of your services. And they have to be absolutely exact. If you're one character out, as has happened to me many times, nothing will work. So you really got to double check. And if you do run into trouble, just download the config file from GitHub and you should be okay. Anyway, so we've specified the name of our cluster IP service, and I'm just going to specify what type it is. And it's of type cluster IP. Capitalize that, and then selector. Tab in, app, and we come up here and we actually pick the name of our template, which is platform service in this case. I'll just make sure I've not copied too much space there. There we go. I'll paste that in here. Again, you've got to get this stuff absolutely correct. We'll back out and then we'll define our ports. And then it's an array. So we'll give it a name. And again, I'm going to give it the same name, platform service as well. Tab in, protocol is going to be TCP. Port's going to be 80, and target port is also going to be 80. And that's it for now. We will add another port onto this for when we come on to doing gRPC, but for the moment we're just using plain old HTTP, so this should suffice. So our actual deployment hasn't changed yet, and we're adding a new cluster service IP into that. So let's just save that off for the moment. We're not going to apply that yet. And then we're going to create a new deployment for our commands service. So right click in here, new file, and we'll call this commands depl.yaml. Okay, and what I'm doing, I'm going to come in here and I'm going to copy all of this. And I'm just going to do a bit of a replace for our command service. Okay, so let's just work our way down from the top down to the bottom and replace the things that we need to replace. So the first thing we're going to change is the name of our deployment. So rather than it being platforms depl, it's going to be commands. The name of our service is going to be command service. And maybe we just come back over to Docker Hub and we just take a quick look. Just double check the name of our service. So it's command service, not plural. Okay, so command service. And I'm going to copy this because I'm going to replace it everywhere. I'm going to push it in here. I'm going to push it in here. And I'm going to push it in here as well. Okay, so binary thistle, command service latest. Let's come down to the cluster IP for this service. And again, we're just going to change this. Instead of platforms to commands, cluster IP is okay, and I'm just going to change the selectors to what we already had. There we go, that all looks good. So if I just highlight this, we should have these same things highlighted throughout the rest of the file, and we'll save that off. Okay, that all looks good. Okay, so just to reiterate what we have done, we have built our command service as a Docker image and we have pushed that up to Docker Hub because we need that for our deployment. And we've now updated our platform's deployment to include a cluster IP service, which has not yet been deployed. And we've created an entirely new commands deployment that contains the deployment for our service and also cluster IP. So in the next section, we're going to run both of these deployment files to get everything up and running. But just before we do that, there is one little bit of config we need to pop back into our platform service just before we do that. So we'll do that next. All right, so I was talking about we need to make a bit of a change to our platforms service config. So back over in platform service, we need to know where our command service resides. And this is one of the problems of synchronous data services. If you're doing it this way, you need to know where all the endpoints are. And so we've created a config entry in our app settings development JSON file that tells us where we can find the command service in a development environment, and that's all cool. But when we deploy into Kubernetes, it's an entirely different environment. It actually runs in production. So this bit of config, number one, is not going to get picked up. And even if it did get picked up, it's going to be incorrect anyway, because the command service is not going to be running here. It's going to be running somewhere else. All right, so the first thing we need to do is create another settings file just for production, just for our production settings. So I might just clear down a lot of this stuff because it's getting a bit busy. And come back over into the root of our project. I'll just minimize some of this to give us a bit more room. And we're going to create a new app settings file in the root of our project. So new file, app settings, .production.json. Okay, and so these are the settings that are only going to get picked up in a production type environment. All right, so we come back over here. I'm just going to copy this. Copy, and I'm going to come over here and create some curly brackets and create this as a top level item. So that's point number one. That's all cool. But where is our command service going to reside in Kubernetes? Well, if we come back over to our K8s folder and we look inside our commands deployment, we have created this cluster IP service for our command service. So again, come back to our architecture diagram because I think it's worth revisiting. Let's come back here. What we are attempting to do is get our two services to talk to each other via their cluster IP services. So really the endpoint from a platform service perspective, the endpoint it needs to reach out to is really the cluster IP service attached to the command service pod. Okay, so the name basically that we need to put in is this here, the name of our service. That is effectively the endpoint our platform service needs to reach out to. So I'm just going to copy that and come back to our platform service. And in our app settings production JSON, I'm just going to replace this here with the cluster IP service of our commands service. And I also need to specify the port. So the name of the cluster IP service, :port, and everything else should remain exactly the same. All right, so again, you know, a little bit kind of convoluted, but you know, there's a lot of config involved in setting all this up. And again, you're probably going to make mistakes along the way. Don't stress if you do. I've made plenty. But the other thing to note here is because I've effectively changed our image now, created some new settings and app settings JSON, I'm going to have to repackage, rebuild our Docker image for our platform service and re-push it back up to Docker Hub. So let's do that now. Let's build it. And let's push it up. So I'm just doing up key, so Docker push binary thistle platform service. And it shouldn't take that long as we've only made a minor change. Now, going forward, you would probably want to extract the settings out of settings file in this way and not have to redeploy images to read in this type of stuff. But again, for this video, I've chosen to do it this way, just in the interest of time. But you can see this probably isn't a particularly efficient way of changing your settings, having to redeploy an image, but that's what we're doing here anyway. So once that's pushed up, what I'm going to then do is we're going to then apply our deployment files, the two files that we've run, and we'll run into another interesting concept when we come to doing that. So there we go, that's pushed up. So I'm going to pause here for a minute and then we're going to come back and we're going to revisit the two files that we've created because as yet we've not reapplied them, and then we'll do our final test to make sure that we get our services talking inside Kubernetes. So we'll do that next. All right, so let's just do a quick sense check of where we're at. So let's come back into our K8s project. And I'm going to bring up our command line. I'm just going to clear that down. So the first thing, I want to just, level set on where we're at because we've done quite a lot of work and it can get confusing. So let's do a kubectl get deployments. Okay, we only have one deployment up and running, which is our platform's deployment. Been deployed, it's all cool, looks good. If you do kubectl get pods, you can see we have one pod up and running, which is our platform service. So again, we've created these files, but we've not yet applied them. And then the last thing we'll do is we'll do kubectl get services. And you can see here we have this Kubernetes cluster IP, which is already there by default, and we have our node port that we created a few sections ago. All right. So the first thing I want to do is I want to apply our platform's deployment again. So quick directory listing, make sure we can see our platform's deployment file. And we're going to do kubectl, apply, f, and the name of our deployment file. So let's do that now. And let's run that. Okay, now you can see a couple of things here. It's saying that the deployment has remained unchanged. Okay, and that's fair enough, because this part of the file, what's really referring to is the deployment here, the deployment we've actually specified in this file, and that hasn't changed. That's remained exactly the same. But what it has said is we've created this new cluster IP service, which all sounds great. So if we do kubectl get services, you should see we have this platform's cluster IP created, which looks good. But coming back over to our Kubernetes session and pulling this over here, we have our pod running and we have our platform service running. What hasn't happened by rerunning that deployment file, Kubernetes hasn't gone up to Docker Hub and pulled down the latest version of our image that has our new configuration pointing to our command service. It's not done that. If we just come back over here and go into it, you can see that, it's not restarted, it's not done anything, whatever. So what we need to do is we need to force Kubernetes to refresh this image. Okay, so the way we do that is we come back over here and we'll just do a kubectl get deployments just to get a list of our deployments again. I spelled that wrong. Yep, there we go. So we've got our platform's deployment. We want to basically restart that or refresh that. So the way we do that, again, this is all in the cheat sheet, these command lines, kubectl rollout, restart, deployment, and then we just specify the name of the deployment. Okay. And then it says deployment apps platforms depl is restarted. And if we come back over to Kubernetes, we should see some things happening over here. Whoop. Or alternatively, rather than doing that, we can just do kubectl get pods. And you can see that we have a container that's running already, but we have this container that's now creating, which is the new container with our new image, with our new config, and it's creating. And eventually this running one, it will terminate once that one has started. So we just have one running now, which is good. And if we come over to Kubernetes and we have a quick look here, you can see one pod has died, and then we come over to our platform service. You can see here, the command service endpoint is here. So it's picked up the right endpoint, certainly, that we've told it to pick up. This is what it will be looking for when we hit the controller. It will then reach out to our platform service. But that won't work at the moment because we don't actually have our commands service deployed. So we'll do that now. And it's relatively straightforward. So back over in K8, let's just clear this out. We'll just do, again, kubectl get deployments. We only have one deployment, so we now want to execute our commands deployment. So again, we'll just do an up key. We want to apply our commands deployment this time. Okay, so kubectl apply -f commands deployment. And you can see this time, we didn't have a commands deployment at all, so it's gone off and created one, and it will pull down the image it has for that. And then it's created a cluster IP service for that as well. Fantastic. So if we do kubectl get services, you'll see we have our two cluster IP services, one for commands and one for platforms, which is good. And then if we do kubectl get deployments, up and running, both are up and running, and we'll do a kubectl get pods to see the health of our pods. And we have two pods up and running, a commands pod and a platforms pod. So that's all looking quite promising. Fantastic. So we'll just come over again to our Kubernetes instance. Let's make this bigger, and you can see we have a pod for platforms, a pod for commands, a platform service, and a command service. And we click on the service, it all looks like it's running okay. So that's looking pretty exciting. So the final step here that we want to do is just test that that is working. So we're going to make a call into our platform service, a post request, and we're going to see if we are talking to our command service. So we'll do that next. Fingers crossed it's all wired up correctly and it's all working correctly. So we'll do that. Yeah, we'll do it next. All right, so let's get testing this. So to test, we're going to use Insomnia. So we're going to be testing purely within our K8's environment. And so all we have so far is the ability to get platforms from our platform service. So let's just run that and make sure that's still running okay. That's good, that's a good start. So what we want to do next is then create a platform in our service running in Kubernetes. So let's come down to our local dev, and I'm just going to copy or duplicate the create platform call, and I'm going to move that into here. Now at the moment we are using a node port, and again we're reliant on this port here in order for that to happen. So let's copy that, and we'll come down to here and we're going to paste that in here. Okay, so hopefully you remember that from when we were looking at node ports. We were just calling a create platform, but we're having to use this node port endpoint. And we'll just, again, we've only got 3 platforms in our platform service, so we're going to create hopefully another one. Now what we expect to see is that, number one, a platform will be created in our platform service. Fantastic. But more importantly, what we want to see in the logs of our command service is that it received that post notification, and if it receives that post notification, then we know that everything is wired up correctly, and we're really quite far down. We've broken the back actually of a lot of the Kubernetes networking stuff, which I appreciate is quite voluminous and quite boring. So fingers crossed, let's click send. Looked pretty good, it came back pretty quickly. So looks like we've created a platform in our platform service. Let's just rerun this. Fantastic, we have. And then the last bit we want to test is we want to come over to our Kubernetes session and just pull it over into the screen. And we'll take a quick look at our platform service first, and we should see that it sent some stuff over to, we've done a couple of calls that was getting a platform. So if we move a bit further up, sync post to command service was okay. So it called the command service okay. It didn't get an error, which is fantastic. It's looking pretty good. And then we come into our command service, and you can see here that we got an inbound post from our command service. So it looks like everything is working very well. Now, the only thing you will notice is that we get this warning around HTTPS redirection. So nothing really to worry about, but if we come on into both our services or either of our services, let's pick our command service and come into our startup file. You'll see down here in configure that we have this use HTTPS redirection. That's what's causing that error. Now, one of the things I decided to leave out of this course was introducing HTTPS, I think I've said this already, into our internal Kubernetes cluster. We're not going to use that. So what I might do, just to get rid of those warnings, I might just comment this out. And of course, as soon as we comment it out, it means we've got to redeploy our stuff back up to Docker Hub. But again, I'll leave you to do that in your own time. I'm not going to do it in the video. This is relatively benign at this point in time, so I'm not too bothered about that. So I might do that in between now and the next video. I might push my images back up to Docker Hub. I'm not going to include it here. If you choose not to do that, it's not a big issue. So I'm going to comment it out of our command service, and then I'm going to comment it out of our platform service as well. So over in startup, I'll do that as well. And in between now and the next video, I'm going to build these images and push them back up. And of course, you would have to do the rollout restart thing to get Kubernetes to pull down the latest version, but I'll leave you to do that at your leisure. And if you choose not to, it's not a big deal. It just means that you'll still get those HTTPS redirection warnings. Fantastic. So that's a big milestone that we've got over. What we're going to move on to next is we're going to move away from using the node port, and we're going to move into using a more productionized mechanism to get into our services, and that's when we start talking about the Nginx ingress controller. So we'll start to move on to that next. All right, so let's just do a quick architecture review just to see how we're doing with our Kubernetes build. Let me just find the right, there we go, the right slide. So we have basically got to this stage here where we have a node port, we have our 2 services running in pods, and we have our cluster IP services wired up so they can talk to each other, which is fantastic. But now we want to stand up what's called an ingress Nginx controller. And as a result of standing that up, we'll also get this load balancer service as well that will allow us to get external traffic in. Now, this is kind of going into more detail about how Kubernetes works. We're going to go through it all step by step, but I'm not going to dwell too much on it, okay? Because we're actually going to be reliant somewhat on an external YAML file that's going to set all this up for us. And really the only thing we're going to end up doing is writing the routing config for this gateway, for this ingress Nginx controller, and the rest of it's kind of taken care of by another GitHub project actually, which we'll take a look at now. So actually that's probably a good segue into that. So let me just come over to Google and let's pull it onto my screen. And if you search for ingress Nginx, be careful because there's a few very similar repositories, but this is the one we want here. So it's GitHub Kubernetes / ingress Nginx. Now, don't worry, we don't need to really do too much with this. If you scroll down to the getting started document, this is really what we want. And this is telling you how we can install this ingress Nginx controller. And we have all these different providers. So if you are running on Google Cloud or something, then you would pick this one, or AWS, you would go with this one. We're using Docker Desktop. So this is all we need, okay? So we're going to copy this here. You can see the kubectl apply f command that you've been very comfortable using for, you know, the last few sections of the video. But this time we're going to specify a URL to where the YAML file exists. So what we might actually do is let's just copy the URL. I can do that properly, copy it, and I'll put it into another browser window, and you can see, and you can probably suggest you take a quick look at the contents of this, but you can see it's pretty big, it's pretty long. I'm glad I don't have to type it out, and I'm sure you're pretty glad you don't have to do it either. But it's still worth going through and having a quick look to make sure you have a sort of understanding of what it's trying to do. But by and large, yes, it sets up this basically an API gateway that we can, you know, route into. So enough of that. I'm going to copy the whole thing now, the whole kubectl apply command. In fact, we can probably just tick this little thing here. That's good enough. And we'll come back over to a command prompt. Let me clear this down. I'll paste this in. And there you go. It's kind of gone through and basically applied everything. So let's take a look and see if we can understand what it's done. So if I bring over my Kubernetes session and go back to the list of running services, you can actually start to see there's a pod here, ingress Nginx pod here. There's a couple of pods actually, and these will work through for a bit until the deployment has settled down. So some of these things will create, recreate, and then destroy themselves. So let's come back over to our command line. I'll do CLS, and again, we'll take a look. We'll do kubectl get deployments. Now, something kind of strange going on. We can only see the deployments that we have done, our commands deployment and our platforms deployment. What about if we do get pods? Do we have any joy there? Not really. We see our 2 pods that we have created, our commands pod and our platforms pod, but where's all this ingress Nginx stuff? Well, again, a bit more of a detailed Kubernetes concept, but Kubernetes works on this concept of namespaces. In a similar way that we've got namespaces for our classes and stuff, Kubernetes works along the same line. So we are working within the default namespace for our project. So we've not really covered that as yet, and I'm not really intend to cover it in too much more detail, but the stuff we've created for ingress Nginx is in a completely different namespace to our application. So just coming back over to the cheat sheet, you can actually look at all the namespaces that we have. So kubectl get namespace. And you can see here we have default, which is kind of where we're working in, and then we have this, we have these kube namespaces as well, which I'm not really too interested in. And then we have this new Ingress Nginx namespace that's being created as part of what we've just run. So we can look at the pods in that namespace by doing kubectl get pods, and again this is on the cheat sheet, namespace, and then equals the name of the namespace, which in this case is Ingress Nginx. I'll do that. Now I might actually make sure that I put 2 dashes in there. There we go. So that's 2 dashes, not 1 dash, and the cheat sheet is correct. I just was misreading it, and you can see here that we have a couple of, well, one running pod basically, which is now our Ingress Nginx controller, and these two things have basically completed. They're no longer running, and that's what I was talking about with these pods that kind of create themselves and then destroy themselves. So that all looks relatively good. So let's come back to Kubernetes, and you can see here, yeah, we've got a couple of ghosted pods. So I might just get rid of these, remove them. Don't need them. And we've got enough going on our screen without having all this extra stuff running. Okay, cool. So we've got a pod for Ingress Nginx controller, and we have a controller, the actual controller itself, and you can go in and have a look. And it's basically running on Nginx, which is similar to Envoy, which is basically used a lot as a gateway type setup. Fantastic, so that looks good, but at this point in time all we've done is set that gateway up. We might also take a quick look at networking, get services. And you can see in a similar way that we've got the services that we have set up for our namespace, but we could get the namespaces for Ingress Nginx, and I dread to think what it's going to show us, but let's take a quick look. And you can see here we've got a load balancer, which was created. It's another service type, and we have another cluster IP service actually as well that's being used there as well. All right, cool. So again, we don't really need to worry too much about that. That's all been set up for us automatically. What we do need to come on to doing now is to create the routing file that this controller is going to use to route to our 2 services. So we'll do that next. All right, so back over in our K8s project, so make sure you have your K8s project selected. I'm just going to clear the terminal screen. I'm actually going to get rid of it for the moment. We don't need it just yet. And I'll clear down these other 2 files. So we're going to create yet another YAML file in here. So right click, new file. And I'm just going to call this ingress-srv.yaml. And this is, again, this is the routing file that the Ingress Nginx controller is going to use to determine how to route to our services. So it's really quite important. All right, so we're going to type all this out. We're going to go slow. Don't want to make too many mistakes, otherwise it's going to be very, confusing and difficult to debug. So specifying an API version. This time it's slightly different. We want to specify networking.k8s.io/v1. So let me just double check that. API version networking.k8s.io/v1. Perfect. I'm going to specify a kind, and this time it's an ingress. I don't want all that autocomplete stuff, so I'll just type it in. Make sure I type ingress correctly though, so it's an ingress. Oh my goodness, I don't want that. So yeah, kind is ingress as opposed to deployment or whatever. Fantastic. And then we specify some metadata. Again, we will specify a name, and I'm just going to call this ingress srv, and then some annotations. And we have 2. And I tell you what, I might actually copy these in from my notes because they're just going to be very subject to typographical errors. And these are just a couple of helpers really that we're specifying that we want our controller to use. Okay, so it's talking about regular expressions, and yeah, we're using this ingress class for Nginx, which is the gateway that we're using. All right, so again, the code is on GitHub. So again, if you don't fancy typing this out, and I don't want to type it out on the video in case I make a mistake, and then it's just a whole nightmare going back and fault finding. So I've just copied those in. Have a go at typing them out, or you can just go to GitHub and do what I did there and copy them in.
Fantastic. So we're going to come back under the main route or indentation layer. So underneath metadata, kind, and API version, we're going to specify the main spec and the rules of, or routing rules effectively. So indent rules, fantastic, indent again, and this is an array. So the first thing we're going to specify is our host. Now, like a lot of these gateways, they actually require a host name. They don't like localhost usually. They don't like IP addresses usually. And I did a whole video on the Envoy controller. It had the same kind of issue. Well, maybe it's not an issue. It has the same constraint. So you have to specify like a domain name. Now, we just want to really route to our loopback address or a local host address. I know they're slightly different, but basically our local machine. But we do need to specify a proper domain name. So I'm just going to specify one here. I'm just going to call it acme.com. And we're going to have to update our hosts file, our local host file, to reflect that acme.com actually redirects to our local address. Okay, so we'll come back and we'll do that in a bit, but just bear with me for the moment. I'll just put that in here. Now you can put anything you like in here. Just remember what you put. If you're following along, I suggest for simplicity, you just put in acme.com like I have done here. All right, under host, we're going to specify it's a HTTP based routing rules. So again, HTTP is directly under host. And then we're going to specify an array of paths. Now this config, it doesn't get much, there's maybe about another 10 lines involved, so don't freak out too much. It's not going to get too much bigger, but it is quite a deep config file, and you have to be, again, I keep saying it, really careful about your indentation, making sure that you've indented correctly, because it can catch you out. So specifying paths, and now I've actually made a mistake myself here, so it's paths like that, and you can see it was actually complaining, so paths is indented under HTTP. Then under that, we start to specify the individual paths that we want, so singular path. All right, so the first thing we want to attempt to route to is our platform's controller, a platform service. So the way we do that is just by specifying the route on top of the base URL. So anything on top of acme.com would be, in the case of platforms, would be API platforms. And then we specify a couple of attributes. Path type is prefix. And then we specify something called the backend, and you can probably guess what that is getting at. Is what service basically are we trying to attach to here? Okay, so the backend, we specify the service, and we specify the name. And the name of the service basically is, if we come over back to our platform's deployment file, it's basically the name of our cluster IP. Okay, so we're going to copy that. So again, platform's deployment file, our cluster IP service, that is the name that we are going to put in here, and that's where we want to kind of direct this backend to. All right, and then port, tab in again, number is 80. Okay, so that's putting in a single route to our platform service at this path on port 80. All right, that all looks correct. So I'm going to create one more path, but this time for our commands service. So I'm actually going to type it out, because sometimes cutting and pasting can be more trouble than it's worth in a YAML file like this. So again, make sure you're specifying your next path as part of this paths array under this minus sign here. So we're going to specify another path, and it will get us used to doing this kind of stuff anyway. So this time the route is API /C. Now again, this is the whole reason I put this C identifier in the route to our command service, because it needs to be different from this, otherwise we're going to run into some issues. So again, platforms, path type, prefix, and then we specify the backend in a very similar kind of way. We tab in, specify the service, we give it the name. This time it's the commands
cluster IP service. So we come back over to our commands deployment file and we come down here. We want this name, the name of our cluster IP service. So you can see this stuff is quite horrible. And again, the video I did on Envoy, to be really honest with you, I didn't really enjoy it. And I'm not particularly enjoying this either. I don't really like this stuff, to be really honest with you. For me, it's kind of configuring API gateways. I don't love it, to be honest with you. And it's so subject to error that, yeah, it's not my favorite thing, to be really honest with you, but it's a necessary evil in this case. And again, we're specifying port 80. So I think that looks okay. There's no warnings in the actual file itself by the looks of it, so that's all good. I think we're ready to go. So I'm going to save that off, and then all we need to do is just run the kubectl apply command, which we'll do next. But before we do that, I'm going to go into my host file and I'm going to make sure that we have an entry for acme.com, but I'm going to do that in the next video. All right, so we want to update our host file now. Obviously, your host file is in a different location depending whether you're running on Mac, Windows, or Linux. I'm running on Windows, obviously, so I'm going to, browse to that location. I will put a link to where you can find your host file on those two other operating systems, but you can probably, to be honest with you, just Google that yourself. The result is basically the same. So I'm just running, as you know, obviously VS Code, so I'm going to just open my host file from within my K8's project. So file open. Now on Windows anyway, you have to basically open it as an administrator, otherwise it won't let you save the file. Or you can save it as administrator, which is what I'm going to do here. So open file, first of all, and the location on Windows is on the C drive. It's in Windows. It's in System 32. Drivers, etc, and then there's what look like a few different host files, but it's this first one here, the one that just says hosts, and I don't believe there's an extension, so we just open that up. And we can see here that there's a few entries in here already. Now what I want to do is I want to put in entry for acme.com or whatever you've put in your ingress service file, and I want to just direct it to 127.0.0.1. You can even see there's some stuff in here that's been put in by Docker Desktop as well to assist with networking. Okay, I'm just going to put this in here, and I'm just going to put in acme.com. So what effect this has is basically whenever we type acme.com into our web browser, it's actually going to look here first before it goes and does any DNS lookup elsewhere. So we're kind of hijacking acme.com. So just remember, of course, that you've done this in your host file, unless there is a site called acme.com that you visit frequently, maybe pick something else. So I'm going to save that, and I'll probably get the warning. So here we go. So it's failed to save, insufficient permissions. So I'm going to retry as admin. And I've just got a pop-up on my other screen saying, do I want to do that? And I've just said yes. Cool, so that should be as good. But what I'm going to do, just because I'm paranoid, is open it up again, just to make sure that save took. Because I don't want to get through to deploying our changes and then find out that something went wrong. So Windows, System 32, drivers. There we go, that's the wrong one. Drivers. And etc, and I'm going to open my host file again, and yeah, the change took, so that's fine. So I just want to double check that that is there. All right, cool. So then all we need to do, as we've done many times before, is basically run or apply this ingress SRV file using our very familiar language so far. So just make sure you're in your K8's project folder. We'll do a listing and make sure you can see your ingress SRV YAML file. So again, it's kubectl apply f, and I'm just going to apply this config. And there we go, we've got this ingress networking K8's created, which looks good. So the moment of truth, we want to try and test this now in Insomnia. And again, just coming back to our architecture diagram, I will just show us where we hopefully have gotten to. We want to try this thing here now. So external coming in through this Nginx load balancer, it's going to hit our ingress Nginx controller, and then depending on what route we put in, it's going to route off to either one of those. All right, so fingers crossed, this is a big moment for us. Now, again, what I'm going to do here is, yeah, we're actually running in the K8's environment. So again, yeah, I might want to specify something different here. So what I might do, because this is using the node port stuff, so I want to differentiate that. So I might just rename this and just call it platform service node port, just so I know those are the node port requests, which you may want to continue to use for fault finding purposes. So I'm going to close that down. Actually, these aren't in here, so we just put these in here. That's better. And I'm going to create another folder in here, new folder. I'm going to call it platform service. And I might just call it Nginx, which is really our gateway proper. All right, so I want to copy this or duplicate it, get our platforms and move it up here under this. So instead of routing to localhost 30,407, if we just put in acme.com here, and make sure we spell it correctly, it should route off to our platform service and pull back all our platforms. So drum roll, there we go, fantastic. So we've now set up successfully an Ingress Nginx controller. Now, we can't quite test our command service yet because the only controller action we have is that stupid post command. Well, I suppose we could test that really, but I'm not going to do it here. We'll come on and we'll check that when we put in some get actions that we can route through to our command service as well. But I'm fairly confident at this stage, famous last words, that this is looking pretty good. Fantastic. So that's probably most of our networking type stuff done now. We're going to do a few bits of repeated setting up of cluster services and stuff. But by and large, in terms of new concepts, we're done. We're done with new concepts around Kubernetes networking. So it's a good place to be in. So we're going to start to move on to what I think now is a lot of the more interesting stuff. So then the next section, we're going to set up our SQL Server for our platform service along with some persistent storage. And we're going to get all that hooked up. And then beyond that, we're going to move into using RabbitMQ and all that really interesting, exciting stuff. So yeah, we're done in this section. Next section is going to be setting up SQL Server. So yeah, we're going to create our SQL Server now. So let's just check to see where that fits in terms of our Kubernetes architecture. So we've got to this stage now. We just created our Ingress Nginx controller in our last video. And now we're going to set up a dedicated SQL Server just for our platform service. And along with that, we'll create a cluster IP address. Now, something new that we've not encountered yet is another new concept. This is the persistent volume claim. Now, all this is something that we will put into the deployment file for our SQL Server that basically, as the name would suggest, stakes a claim to some physical storage, in this case, on my machine. So just staying on that theme for the moment, if we do a kubectl get storage class, make sure I spell it correctly, we have one storage class. So what's a storage class? Well, there's three concepts really when you're talking about storage. Well, three basic concepts you need to understand. The first one, and really as a developer, the main one you need to understand is the persistent volume claim, which we're going to create. Then you have something called a persistent volume, and then you have this thing called the storage class. So thankfully, all we need to create is the persistent volume claim, and that will use our system defaults, and ultimately we'll use this storage class, which is effectively, in our case for Docker Desktop, just our local file system. If you were using a more enterprise deployment of Kubernetes, say in Google Cloud, you would have to set up all of these things independently, and that's when you start to move into this more administration type role rather than the developer role. As a developer, all I'm really interested in is making a claim to some storage. Other than that, don't really care, to be honest with you. So I'm going to leave it at that, and we're going to move on and create our persistent volume claim in our K8's project. So yeah, in our K8's project, just right click anywhere. I'm going to do a new file, and I'm going to call this local, as it's going to be on our local disk, local pvc.yaml. So local persistent volume claim.yaml. Let me get rid of the terminal for the moment. And API version, and it's going to be v1. Make sure we put the colon in the right space. And the kind this time is a new kind. It's persistent volume claim, and I want to get the persistent volume claim. I don't want to type that, but I don't want all this default stuff. So let's, oh goodness. Actually, I can probably take most of this. I just don't like doing too much auto-generated stuff because it kind of gets a bit lost on everybody. So yeah, let me take this out. That's why I was getting confused. Okay, so API version v1. The kind is persistent volume claim. We are going to have metadata, and we're going to give it a name, and I'm going to name it MSSQL-claim. So Microsoft SQL Server claim, if I can spell claim correctly, that would be useful. And then spec, we're going to specify how this persistent volume claim is made up. So the first thing we need to specify is something called an access mode, or access modes, and it's an array. And I'm going to specify that it's read, write, many. So we want it to read, we want it to write. Then the next thing is our resources. And really this is where we're staking our claim to the storage resources or the persistent resources that we want to use. And it's resources, requests, and then storage. Typing's really starting to suffer now, and I just want 200 megabytes. I don't want a huge, massive disk size, so that should be fine for us. Now, this looks rather sparse, and indeed it is, and you can obviously specify more things in here. But for now, if we just leave it at that, Kubernetes is smart enough just to use the defaults, which will give us access to our local file system. So save that off, and then bring up your command line. We'll just clear this off, and we'll do a listing just to make sure we can see the local PVC file. And then as usual, it's just kubectl, apply f, and then the name of our file. I'll paste that in there. And you can see here that our persistent volume claim has been created. So if we do a kubectl, get PVC, you will see that we have a persistent volume claim created. Status is bound. We've got our access mode, which is read and write. We've got our capacity, and we've got our storage class here, which is host path. And if you remember from when we got our storage class, that is what our storage class is, host path. It uses it by default. So that's it really for the persistent volume claim. The next thing we need to set up just before we actually go on and create our SQL Server is SQL Server, when we set it up, will require a system administrator password. Now, again, for a lot of the config I've got in this tutorial, a lot of it is just stored in config files, which is not best practice, but again, in the interest of time, that's what I've done. But here, what I'm going to do, just to show you how you can use something called secrets, I'm going to actually create the SQL Server password as a secret in Kubernetes, and we're going to pull that in via a config file. So it kind of removes this idea that you're actually storing sensitive information in config files, which you generally don't want to do. So we'll do that once, and then we'll move on to actually setting up our SQL Server. All right, so let's just clear the screen here. And what I'm going to do here is I'm actually just going to issue this command, obviously, at our command line. I'm not going to create a file because, again, it would defeat the whole purpose of having something that's secret if you actually put it into a file, because then you just have the same circular reference of bad security. So we're just going to issue this at the command line and not store it anywhere. So it's actually a bit like user secrets. If you've used user secrets with .NET development, it's kind of similar concept to that. In fact, very, very similar to that. So at our command line, we're going to use kubectl, obviously. We're going to create secret of type generic, and we're going to call it MSSQL. And we'll make use of this MSSQL name in a bit when we actually come on to creating our SQL Server. Then -- from -literal, and then we specify basically a key value pair for the key and the value. So the key in this case is going to be SA_password, all capitals, and the value is going to be our password. And I'm just going to use, well, you can use whatever you like. I'm going to use this. So let me just check the spelling. I've checked everything is spelled correctly. So kubectl, create secret, generic, MSSQL, -- from, literal SA password. That looks good. Okay, so we have our secret created. Fantastic. So we just make sure that we remember these two things here, this name here, and also the key that we defined. So now we're actually going to make use of this when we come on to creating our deployment for our SQL Server. So we'll move on and we'll make use of our secret as well as our persistent volume claim, and then we'll stand up a new instance of SQL Server. All right, so here's the main event of this section. We're going to create a deployment for our SQL Server. So I'm just going to get rid of our terminal because believe me, we're going to need the room. This is it's actually the longest file that we're going to write, the longest deployment file by a mile that we are going to write. So in our K8s project again, right click, new file, and I'm going to call this MSSQL-plat, as in for our platform service. It's going to be dedicated to that. depl.yaml. All right, so we'll specify an API version of apps v1, and I need to be really careful what I type here because there's a lot of stuff going in, so I'll double check every line as I type. The kind, we've come across this before, is a deployment, and I don't really want that, so I'm going to just type it out, deployment. And the metadata, we're going to supply a name, and that is going to be MSSQL depl. So that's really the name of our deployment. So when you do kubectl get deployments, this is the name that will come up. And if you wanted to destroy this deployment, this is the name that you would refer to. All right, so nothing that we've not seen before. And again, we're going to come on and define the spec. So tab in. We're going to define number of replicas, so 1. And then we're coming on to the usual selector stuff that you've seen quite a few times before. I'm going to use some match labels, and then we're going to call our app MSSQL. Just MSSQL. Okay, oh my goodness. Autocorrect is quite annoying sometimes. Okay, so bring your cursor back under the selector, and we're going to define the template this time. Specify some metadata. You can probably tell I'm not a huge fan of YAML files. The only thing I do like about them is that you can put comments in, which you can't typically do with JSON, so that is their one saving grace. So anyway, template, metadata, labels, app, again, is MSSQL. So you've seen this selector template thing before. Okay, new line, and bring your cursor underneath the metadata, underneath template. Again, be really super careful. I can't really stress it enough. Be super careful about how you type this stuff in, because one mistake and it's game over. So we're going to specify the containers that we want, and again, this is an array. In this case, we are just creating one. So I'm going to give it a name of MSSQL, and then bring the cursor under the name. We're going to specify our image, and this is where we specify the Docker image for our SQL Server. So it's mcr microsoft.com/MSSQL/server : and I'm going to use the 2017 version of SQL Server, the latest version. Then I'm going to specify some ports, and we're going to specify the default SQL Server port, which some of you may know is 1433. So bring your cursor back underneath the ports, and then we're going to specify some environment variables, and this is where we're going to kind of inject in our secret along with a few other environment variables. So minus sign, we'll give the first one a name of MSSQL PID. Tab in and give that a value of Express. So basically that's saying we want to use the Express version of Microsoft SQL Server as opposed to the developer edition or whatever. And this edition is of course free. So we're going to create another environment variable, give it a name, and this one we'll call accept EULA, and the value is going to be yes. Now that's just accepting the license agreement as per, you know, Microsoft's usual kind of way of doing things. And then we're going to specify one more, and this is where our system administrator or SA password comes into play. So the name is SA_password. And just as a matter of interest, if you were just running SQL Server, and I've done a few videos on this, if you were just running SQL Server in Docker without using Kubernetes, you actually have to pass in some, well, exactly the same environment variables as part of that. So if you Google SQL Server Docker, you'll actually see some very similar setup required just to run SQL Server as a container. So again, we're just doing that here, obviously, but albeit in a Kubernetes deployment. So we're not going to specify an actual literal value, because again, that would negate the whole point of setting up a secret. So we're going to use this thing called value from. And where are we going to get our value from? We're going to get it from a secret key ref. Okay, take a new line, tab in again. What's its name? MSSQL. And again, well, if I bring up my command line, I should be able to, it should still be there, I think. It's basically this thing here, okay? The name that we gave it here. And then the other one is, here's SA password. So again, that's where SA password is coming in. Here's our key here. All right, so that's all that's pulling in. And the key we have to specify here is SA password. Okay, so the name of the environment variable is SA password. The name of the key that we gave it is SA password. Let me just highlight that. That's the same. That's cool. Okay, and that's it for our environment variables. So we need to take a new line, and we need to take our cursor underneath the env. Okay, and here we're going to specify volume mounts. And we're going to give it a mount path, and this is just the mount path of when SQL Server runs. Now we're actually running, this image here is the SQL Server running in Linux, so the mount path is going to be like a Linux-based path, and it's just really going to tell us where our database is going to reside, where our data for our database is going to be. So it's var opt mssql/data, and we'll give it a name of mssql_db. Not DV, DB, B for Bravo. All right, almost there. Well, almost there for this part of it. We've still got the networking stuff to go. So we're going to bring our cursor out underneath our containers. So again, Visual Studio Code is quite nice. It does give you the kind of line marker to kind of help you not go too cross-eyed. And I'm just noticing here under volume mounts, I need to bring this back like this, and I need to bring this back like this. That's better. And volume mounts is underneath our env. That's correct. So yeah, this stuff is pretty painful. I will not kid you. I don't particularly love it. Anyway, okay, when I auto-generate it, it's actually doing that for me, but I'm going to leave it like that. Okay, so mssql_db is the name of this, and this is really where we're setting up our persistent volume claim. Persistent volume claim name. If I come back over here to our persistent volume claim, it's this thing here. This is the name that we want to, or the claim name that we want to use. So we'll come back over here. Claim name is that. Okay. So you'll notice this pattern when you're doing these deployments. You reference other objects that you've created elsewhere. So you just have to make sure that you're creating the right thing. So I think that all looks correct. I mean, obviously when we run it, we'll find out whether it's incorrect or not, but I'm just checking it against my notes to make sure it's correct. Yeah, so I mean, it's kind of done some indentation that I've not used in my notes, but I think it will be okay. I think that should be okay. All right, we'll find out if not. So that's it for defining our SQL Server. You'll be very pleased to hear, but what we want to also do is create a cluster IP address so it can talk to everything else within our cluster. So down here, I'm going to take a new line. Now, as I don't particularly want to do too much more typing, I'm going to copy the cluster IP address spec from one of our other deployment files. So I'm just going to come over to our commands deployment, and I'm going to come down to where we specified the cluster IP address for that, and I'm just going to copy it. Now, obviously, we have to change some settings in it, but that's okay. That's preferable to typing it all out again. So at version v1, the kind is service, the name we're going to change, and we're going to call it MSSQL cluster IP -srv. So the spec type is cluster IP. The selector, and again, this is where we want to actually select the thing that it's going to network, is basically this here. So we want to copy MSSQL and put that in here twice, basically. So I'll take this out, paste that in. I'll take this out, and I'll paste that in. Protocol is TCP, but the port and target port are both going to be 1433, which again is the default SQL Server port. All right, so that's good. Now, we could leave it at that, but I actually want to be able to access this SQL Server from my desktop. I want to be able to kind of drill into it directly. Now, we can't do that through our Ingress Nginx controller. We could create a node port. I think that would probably work, but there's another service that you can create called a load balancer. We've kind of already sort of seen it with part of the Ingress Nginx stuff. So we're going to actually create a load balancer service, which does similar stuff actually to the node port. It will allow us to actually directly access this. So let's go through and do that. Now I think I can probably copy this and we'll just change the relevant bits and pieces as we need to. So again, API version 1, it is a service. We will give it a name of MSSQL load balancer. Now, I don't have this on our architecture diagram. You might go, where is this on the architecture diagram? It's not on there. I deliberately left it off because I didn't want it to become too confusing. And we're actually, when we create a RabbitMQ server, we're going to do something very similar with it as well. We'll create a cluster IP and also a load balancer that we can use to access it. But again, I didn't want to put that on our diagram because it'd get a bit too confusing. Now, you don't have to do this. This is somewhat optional, but I think it's probably going to help us out, to be honest with you. Anyway, back to this. In our spec, we're specifying that it's a type load balancer. The selector is the same, MSSQL. And ports, we don't need to give it a name, so we'll take that out. And we need to put in the fact that this is an array. Now, if we're specifying more than one port, we would need to give it a name, but we don't in this case. So ports, TCP, and again, we'll leave the ports exactly the same. That should work for us, I think. All right, so let's just do a bit of a review. This section is our deployment of our SQL Server. Hopefully we've typed it incorrectly. We'll find out in a minute whether it's not correct. Here's our cluster IP, which you've seen before, and here's this new concept, well, semi-new concept of a load balancer. So I'm going to pause here for a minute, and then we're going to come back and we're going to apply this deployment and see if we can access our SQL Server. All right, the moment of truth. Now make sure you save your file. And we'll bring up our command line again. We'll clear the screen, and I'll maybe move this up a little bit. Do a directory listing to make sure that you can see your MSSQL plat deployment. And again, you should be getting used to this now. kubectl, apply, F, and I'm just going to copy this in. And this is the moment of truth. If we made a mistake, we'll get an error here. Now that all looks good. So certainly the YAML that we've created is syntactically correct. So you can see here, again, you should be getting used to this now. A deployment's been created. We've got a cluster IP service created, and we also have a load balancer created. So let's do quick clear the screen, and we'll do kubectl get services. And we should see our SQL Server load balancer available to us on localhost, and we should be able to access our SQL Server using one of these ports here. And then we have our cluster IP service, again, internal to our cluster, available on port 1433. Fantastic. And then if we do kubectl get pods, we should see that our SQL Server is still creating. Now, it could well be that I don't have the SQL Server images getting pulled down from Docker Hub. So we'll just have to keep an eye on that. And hopefully we don't get any errors and it runs up correctly. Now, I've found from my own experience, if anything is wrong with the persistent volume claim or anything like that, and you can't actually mount to the mount point, that's where I've had errors before and it's caused me a few headaches, but I'm hoping that this gets created correctly. So maybe if I bring up the Kubernetes user interface, we can have a quick look and see what's going on here. So that's the pod running. I'm just waiting to see whether we have a SQL Server running. Not as yet, not as yet. So that's still container creating. So I think it must be doing some stuff in the background. So we're just going to have to wait for this, unfortunately. Let's have a look at that now. Okay, cool. So we have a SQL Server pod up and running. That's looking pretty good. And I'm looking on my other screen here. I've got my Kubernetes kind of user interface up and running, and I can see here that we have SQL Server up and running. That all looks pretty good to me. All right, so what I want to do, quick test, I want to fire up SQL Server Management Studio, and I want to see if I can connect in. So I'm just going to pull that onto the screen here. I'll just resize it, and I'll just connect. And what I want to select is localhost 1433, and we're going to put in the SA password that we specified. Make sure I type it in correctly. And that's looking pretty good, actually. So we've connected in localhost port 1433, and yeah, we don't have any databases on there yet, which is, yeah, it's looking pretty good. So what I might do, just to test the persistent volume claim is working, although the fact that it's up and running suggests to me that it's working fine. I'm just going to quickly create a test database. It's just, doesn't matter what it is. And we'll just create that, okay? And I'm going to kill that. And then what I'm going to do is I'm going to come back over to Kubernetes here, and I'm going to find our, not our pod, I'm going to find our SQL Server container, this one here. And as I've showed you this before, I'm going to kill it. Just delete it. Let's remove it. So it's gone. Now again, there it goes, this one sort of pinging back. As I've said before with Kubernetes, because we've told it via our deployment that we want one running SQL Server, it's going to basically do anything in its power to make sure that that is happening. Looks like we've killed that a few times, don't think I can kill it anymore. And so what I'm wanting to see is the fact that when that SQL Server bounces back up, that it will be using the same persistent volume claim. Login. Great. And we open this up. And there we go, our test database is still there. So you saw our container being destroyed and rebooted and all that kind of stuff, and we still have the database that we created. So we can delete this now, we don't actually need that. It was just as a test. Fantastic, so that's good. We've got our SQL Server up and running. We can connect into it externally using this load balancer concept. It should be networked internally. So now what we want to do is we want to actually update our platform service to actually use SQL Server. So we'll do that in the next section. All right, so with our SQL Server now up and running and accessible, which is cool, we're going to turn our attention now to our platform's service, and we're going to set it up so that we can connect to that SQL Server in production in Kubernetes. Now, I think as I mentioned before, when I run this service at the command line, .NET Run, I still want to use the in-memory database. So we're going to have to pick between are we in production, are we in development, and then pick which database we are going to use, or database provider we're going to use. Now, some of you might think that's a bit convoluted. There's various reasons why I made that decision. It's up to you. If you actually want to use SQL Server in development as well, you can absolutely do that. And the way we've set this instance of SQL Server up, as you saw, it's accessible locally as well. But I'm choosing not to do that, and I'll leave it over to you if you want to follow that along. But I suggest if you're following along, you go with what I'm doing here. Anyway, with that being said, the first thing we want to do is create a connection string for production. So with that being said, we're going to come over to our app settings.production.json file, and we're going to add in a connection string that will allow us to connect in to our SQL Server running in Kubernetes. So comma at the end of this attribute here, and then we're going to specify another one called connection strings. Okay, and then take a new line, and then we'll specify, you could specify multiple connection strings here. I'm just going to specify the one that we want, I'm just going to call it platforms con. Doesn't really matter, to be honest with you, as long as it makes sense. So platforms con, platforms connection, and then we specify the connection string. Now this is a connection string for SQL Server. If you're using some other database like Postgres, it would be slightly different, similar but different. The other thing I'll say here is be really, really, really careful that you type everything in absolutely correctly, because this is the type of thing that will cause all sorts of issues if you don't get it absolutely precisely correct. So can't stress that enough. Anyway, I'll do a Control B just to give us a bit more room, and I'll start typing out my connection string. So server equals what? That's the first sort of stumbling block. What is the server we're connecting to? Well, if we come back to our K8s project, K8s, there we go. I'm getting confused, too many projects open. So over in our SQL Server deployment file, here's our deployment of our service, but here is our cluster IP. And again, similar that we've done before, we want the name of our cluster IP service. That is basically what we are connecting into. So we'll come back over here and we'll specify that as our server name, comma, and then the port 1433, then a semicolon. So this is basically our server configuration. We're then going to specify the initial catalog, and that's basically the name of our database. So I'm just going to call that platforms DB. Semicolon again, we're going to specify the user ID, and I'm going to make that equal to the SA account. Now, typically you wouldn't use SA in production. In fact, you wouldn't ever use it at all. Again, just for quickness, I'm deciding to use it. And likewise with password, you wouldn't typically put a password in here, but again, just for quickness, I am going to do that. But calling out is not a great idea. So we produced a secret for our SQL Server, and we read that in from the deployment file. You could do something very similar with this, and you could actually inject environment variables into our platform service. But again, it's kind of taking us away from the core of what we're sort of looking at. So I'm just putting it in here, but yeah, just be aware it's probably not a fantastic idea to do so. And I'm just going to put a semicolon at the end there. I don't think it matters too much, but I'm just going to do that anyway. So that's our production connection string available. Next thing we want to do is come into our startup class and configure it so that it will work with either the in-memory database, or if it's in production, use SQL Server and use this connection string. So we'll do that next. So still within our platform service project, I'm just going to do a Control B to bring up our directory listing and come over to our startup class, and Control B again to bring it down. Now, as you'll remember, within our configure services method, we already set up a DB context that uses the in-memory database, which we want to retain, but we also want to add one in now for SQL Server, but not use them both at the same time, as that would be rather confusing. So we want to be able to switch between them depending on what environment we're running in. Now, in order to determine what environment we are running in, I need to inject something called a web hosting environment into our startup class up here and get access to the environment that way. So I'm going to do that first. So in our startup class, in our constructor, I'm going to inject in an iWeb host environment. I'm just going to call it env. Now, this is available to us. There's a few things like configuration, like web hosting environment, that are available to be injected into classes at any point in time. We don't have to set them up within configure services, obviously, because that would be a bit of a circular reference. So this is available to be injected, so you don't need to worry about any other setup from that perspective. And then over here, we'll just declare as usual a private field that we will assign our injected instance to. So again, Control period to generate the read-only field, and it puts it down here. Now I'm just going to move these two things up above our class constructor. Don't ask me why. I just think that's where they should sit. That's just my own preference, though. You don't, of course, need to do that. Fantastic. So that gives us access to this env object, where we can now use it to determine whether we're running in production or not. So coming down into configure services, I'm going to create an if statement, and I'm going to make use of our env object, and I'm going to make sure it's an underscore env, and I'm going to determine, is it production. And if so, we want to set up our SQL Server. If not, then we will just use our in-memory database as a bit of a catch-all. All right, fantastic. So all we want to do now in here is set up our DB context that uses SQL Server. Now, what I might do in here is just do a console write line, just so when things are starting up, we can see what is being picked up, and this will come in very, very useful if we start to hit any problems. So I'm just going to say using in-mem DB. All right, and then likewise, I might actually copy that up here, and I will say using SQL Server. Using SQL Server DB, cool. And then all we need to do is just set up our DB context. So using our services collection again, we're going to add a DB context. DB context, it's going to be exactly the same DB context, so app DB context, fantastic. And likewise, we're going to use some options. You can see it looks incredibly similar to what we've already done for our in-memory stuff. I'm going to tab that in, and I'm going to say OPT. So instead of use in-memory database, I'm going to use SQL Server. And then I'm going to pass in the connection string. If you don't get use SQL Server, you might have to add a namespace by doing control period and bringing that in if you don't have that already. And then in order to get our connection string, all we have to do in here is make use of our configuration object, configuration, get connection string, and to say this is why you actually wanted to call this thing connection strings and give it that exact name. That allows us to use this get connection string method. And all we need to do is supply the name of the connection string we want to use. So we'll come back over here and we'll copy this in. All right, fantastic. Save that off. So if we're in production, we'll use SQL Server. If we're not, then we'll use the in-memory database. So what I'm going to do, just as a quick test, I'm going to run this now, and it shouldn't make any difference now. Should still be using the in-memory database. Shouldn't get any errors. It all looks good. So again, we're using the in-memory database. We're connecting, seeding data. All looks good. Shouldn't really have made any difference at this point in time, which is looking great. So the only other thing that I want to be able to do is apply migrations when our database starts up, if they've not already been run. And I want to do that from within our PrepDB class. We're going to have to actually create some migrations, which we will do at our command line. We have to do that anyway. And then the application of those migrations, we can either do at the command line, or we can set up our class to apply those migrations. So I'm going to set up our class to do it, which makes things a little bit more complex, but I think it's probably a slightly better approach. So before we generate any new migrations, what I want to do is I want to come back over to our PrepDB class and get it to apply migrations, but only if it's running in production. If you try and apply migrations when something is running in development, and therefore using the in-memory database, it's not going to like that. So we have to again make this kind of determination when we apply migrations that we're only doing it when we're running in a production environment. So we'll do that next. Okay, let's do a Control B and go into our data folder and select PrepDB, and Control B again to bring it down. So where I want to actually apply our migrations is when we come to seeding our data. I want to just put it above this section here where we seed data. And I want to be able to determine whether we're in production, in which case we apply migrations, or we don't. So the first thing I want to do is determine if something, and we don't know what that is yet, maybe put a question mark in there. If that's true, then I want to use our context, and I want to access the database, and I want to run migrate, and that will migrate our migrations, which we've not yet created. We still need to actually create and generate our migrations, but assuming we have those, that will run our migrations. So here, I want to basically understand whether we are running in production or not. So how do we do that? Well, the quick way I'm going to do it is by coming back to our startup class. And when we call this method here, additionally, I'm going to pass over again, we have access to this env object here. I'm going to pass over env is production. So if it's production, we're going to get a true here. I'll save that off. It's erroring out, obviously, because that's not what the method signature currently is. So if we come back over here, up to our method signature, which is prep population, we're going to expect it to take in a boolean of prod. Or maybe we call it is prod. Slightly better. So is prod. If it is, obviously it's true, then we want to percolate that down, if that's the right expression to use, down into our seed data method. So we're going to expect that also to take a bool called isProd. And then finally up here, along with passing over our DB context, we're going to pass over our isProd value. And that should hopefully stop everything from erroring out. And then finally down here, we'll just say isProd. So if it's production, we'll migrate. Otherwise, we won't do anything at all. Now in here, I'm going to put a console write line just to let us know that we are applying migrations. So I'll say something like applying, attempting to apply migrations, ... Okay, and we probably should put this in a try catch block, because potentially this is something that could go not quite right. So we will do that, and we'll say catch an exception, and we will then write out console write line. We'll use string interpolation, and we'll say could not run migrations, and we'll give the reason, so curly brackets, ex message. All right, so I think that's us covered. Now again, I'm going to save that off, come back to our startup class. This is still going to get called. It will be running in development, so I just want to run it again and make sure we've not broken anything. So we shouldn't see applying migrations or anything like that. It should all be totally benign. So we come over here, yeah, we just see seeding data using a memory database, so that's looking good. Hopefully, when we do come to deploy it into Kubernetes, that will kick in and it will apply the migrations. Fantastic. However, there is one thing we still need to do, and I actually forgot to do this, and I had to come back and re-record this. I don't know why I forgot it, but I did forget it. And the thing that I forgot to do was actually generate the migration. So if you've worked with Entity Framework before, you will understand that you have to do a generate migration, and that actually generates a folder within our, if I do a control B, that generates a folder within our structure called migrations, and it actually has the instructions that we will run against SQL Server in this case. And I didn't do that, I forgot completely about that, and ended up in all sorts of trouble. So we need to do that first, we need to do that now. So we're going to do that in the next section. A little bit convoluted, but we'll get that up and running, and then we're then ready to push this all up to Docker Hub and redeploy our platform service, and fingers crossed everything should be working. But let's generate our migrations next. All right, so we want to generate our migrations now. So the way that you will do that is we come back to our project and do control backtick. We'll do .NET EF, don't forget the EF, migrations, add, and then you give your migration a name. So we'll call this initial migration and see what we get. Build start, build succeed. We get some horrible looking error. So without going into too much detail, I was expecting that to happen. And the reason that's happening is because Entity Framework Core thinks we're using an in-memory database, and we are in fact using one, and it just doesn't support migration. So we need to basically trick, if you like, our command line into thinking that we're actually using a SQL Server database or some database provider that supports migration. So there's a few things we need to do here, and it's a little bit kind of convoluted. And this is where you might come to the conclusion that you want to use SQL Server in both cases, in both production and in development, because it actually would make this a lot simpler. And all we need to do is just change our config file, which we're going to do. We're going to have to do that anyway as well. So again, this might be an inflection point where you go, I don't like what I've done here. I want to use SQL Server everywhere. That's entirely up to you. But I'm going to keep going with this because, to be honest with you, it's good practice it's a good bit of learning to understand what we need to do to kind of fake this a little bit. So all I'm going to do is I'm just going to take out or comment out this if statement. And I'm not going to even determine whether we're running in production or not. And this, again, this is only to get our migrations up and running. We'll uncomment all this again, don't worry. So at the moment, uncomment that out, we're going to be using a SQL server. All right. And we'll come down here and I'm going to just comment that out. I don't need this to run. I don't want this to run just yet. So I'm going to save that off as well. Now, the only other thing is it still thinks we are running in a development environment. So it's going to come to development settings and see if we've got a connection string. And in fact, we won't. We've only got one in production and this will not get read in at all. So we're going to have to come over here and we're going to have to copy this. And we're going to have to put it into our development settings as well. The only thing though is this will not work. This is only for use when we are within the Kubernetes cluster. So we're going to have to change that. Any idea as to what? Localhost. So that should be enough. I'm just going to come back to our startup class and just double check. So we've commented this out. We don't want that to run yet, and we don't want to make that determination. We just want to use SQL Server. All right, so control back tick. We'll do up key, and we'll see what we get now. Fantastic. So that all looked good. We're using SQL Server DB because we forced it to. And what you should see over here is this migrations folder has been created for us. And inside of here, you can see that we actually have our migrations being created. And it's basically just a list of instructions telling SQL Server how to create our tables and all that kind of stuff. So that's cool. We've got that now. So what we can do now is we can roll back the changes that we sort of hacked there. I'm going to use that term. And we can have an attempt now at packaging this up, pushing it up to Docker Hub, and then running it in Kubernetes. And we will see what we get. So again, we're going to go back to this setup here, and yeah, it will run in memory, in development, and it will run SQL Server in production. When it does that, we'll come down to prep population, and it will actually attempt to run these migrations that we've now created and migrate our database. And if it's successful, then we will see the creation of a database in SQL Server. So getting quite exciting now. So going to pause here for a minute, and then we're going to build this image, push it back up to Docker Hub, and then redeploy our platform service deployment. And we should see everything come together and working as we're expecting. So we'll do that next. All right, so back over in our project, just at our command line, we are going to build our platform service again. So just do a directory listing to make sure you can see the Docker file and make sure you're in the right space. And then as usual, Docker build t your Docker username, name of the service, and then the build context, which is just where we are at. So a period, so platform service. And again, you know, I can't say it again, I can't say it more times. Be really, really careful every step of the way that you spell everything absolutely correctly. One small mistake and things won't work. And I absolutely said it before, guarantee you will make mistakes. So, and if you do get problems, it's more than likely going to be some stupid typo somewhere. I've done it plenty of times, so you will not be alone in that if that happens to you. So we'll just let this build. Cool, that looks like it's built okay, and then we're just going to push it up to Docker Hub. So take out the build context, take out the -t, and we'll just put in push, and we'll push it up to Docker Hub. And then the proof of the pudding is going to be we'll do that rolling restart of our deployment, because as far as Kubernetes is concerned, the actual deployment file for our platform service hasn't changed. We've not changed that. We're just going to do a roll restart so it pulls down the latest image, and we'll see what we get. We'll find out at that point whether we've made a mistake. All right, so that's pushed up. Now what I'm going to do is just come over to Docker Hub and just check that it was updated. Now the reason I like to do this is just in case I maybe misspelled the service name and spelt platform wrong, and we had platform service as well as platform service or something silly like that, which I have done before. And then when you do a rolling restart, you're not actually applying the new image down. And then of course you can come over here and you can have a look and see when it was last updated, and it did say a few seconds ago, and we don't have any weird duplicates or anything like that, which looks all good. All right, so with that being done, I think it's time to move on and actually do a roll restart and see if our migrations are applied to our SQL Server running in Kubernetes. And if we get that working, it's another big massive tick. So we'll do that next. So I will just minimize this, and we can do this from any command line actually. We don't need to do it in our K8s project or anything like that. So let's just clear the screen here. Let's just do a kubectl get deployments. And you can see here we have our 3 deployments, which is looking good. And we want to basically refresh, roll, restart this one here. Okay, so as before,